Exploratory data analysis, also known as EDA, is used by data scientists to analyze and investigate data sets and summarize their main characteristics, often employing data visualization method. It helps determine how best to manipulate data source to get the answer you need, making it easier for data scientists to discover patterns, spot anomalies, test hypotheses, or check assumptions. EDA is primarily used to see what data can reveal beyond the formal modeling or hypothesis testing task and provides a better understanding of dataset variable and the relationships between them. It can also help determine if the statistical technique you are considering for data analysis are appropriate or not. So without any further ado, let's get started right away. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments. Now, before we start our video, let me very quickly walk you through the agenda of today's course. In today's course, we are going to learn about the basics of EDA with Python, multiple variate analysis, outlier detection, Cricket World Cup analysis using exploratory data analysis.
Right, guys. So when I say exploratory data analysis, what is the first thing that comes into your mind? What is this train of thought, that you are governed with, that you understand, right? Let me give you an example. Think of this particular situation, right? So there's a new TV show that has come out, maybe on Netflix, Amazon Prime, YouTube, Hotstar, wherever it is that you guys watch it. And that now it is super trending in a way where all of your friends are talking about it, right? We have multiple shows which did this in the past, saying, hey, friends would ask you saying, hey, did you watch that show? It is very trending and all of that. So now your friends are all talking about all of these. It is in the news, it's on the TV, it's on your Instagram, it's on Facebook. It is everywhere, right? So on the whole, right now, you do not know much about the TV show apart from that. It exists. What would you do? The first thing is, if you really are interested into it, if you can, actually have time to watch it and all of that, you will be curious to learn more about it, to understand more about it. So you might search on Google, watch a video on YouTube, all of these things, right? So what are you doing? You're exploring to understand what is the thing at hand here, right? Again, this is exactly how exploratory data analysis works as well. At the end of the day, you are more and more curious about what you can find in your data. So once you go ahead and sort of tap into that potential, the immense amount of potential that exists in your data, you would be very clear with how things unravel, how things wrap out and give you so much more information than what you could pick up, right? So this is a very beautiful example just for that. So to come towards understanding what exploratory data analysis itself is, first of all, you must begin by looking at the data to understand what it is. Now, data can be understood in multiple different ways, on a low level, on a high level, on a mid-tier level, to see what it is that you're getting for your money, right? Here in the case of exploratory data analysis, we're trying to investigate, we're trying to look into the data and we're trying to see, hey, is there anything that I can find when I look into this data, and eventually have a result which will add meaning to the entire exercise that we are doing. That is exploratory data analysis, right? Sometimes it is not, not all the times it is the case that you'll only be looking for trends and all of this in your data. Sometimes you'll be performing in-depth exploratory data analysis to find out if there are certain anomalies in your data. If your data is working fine, it is doing things the way it should. Is it the other way around? Are there errors in your data which is eventually hurting maybe machine learning or deep learning systems down the line? Or is there anything that is going wrong in your data that you can find out by performing some analysis on it, right? This is exploratory data analysis in one picture, guys. Next up, you really have to understand why exploratory data analysis is so important. It is the requirement of the hour and all of these things, right? There are multiple different points. We can talk about this for hours on end, but the first important point you really have to understand is that whenever you're taking, a look at data to understand what conclusions you might arrive at, to do it, to take a look at data, to understand data means you're already trying to assess and analyze something, right? That is one important point. It will get you to your goal quicker. The second thing is it is very easy to make assumptions with data saying, hey, all the rows in my data are fine. There are no errors and all of that. So if you want clarity about these assumptions that you make, if you want facts which back up everything that you say, and of course what your data shows at the end of the day, it becomes vital that you have a methodology to do it. Guess what? EDA is how you do all of that. The next thing, as I've mentioned, to spot new trends, to know that, hey, here is the product at hand. There is a good chance that down the line in the next 2 months, 3 months or 3 years, this product might be extremely trending. So we have to work on it, right? Now that summer is approaching, a lot of summer wear, light clothes, sweat absorbent clothes, and all of these will be on sale. So to know that if you are a person who's into selling all of these, you will be ramping up on your production scale because you will have such a high demand for it, right? That is exactly my point on this particular topic. So it is not just with data, it is not just you stating out something, but your data is packed now with good amount of proof saying that, hey, this is what I say and I have backup and I have proof for all of that. So that is an important thing you have to know about when you're investing your time learning about exploratory data analytics. Okay, so all of this is amazing. Can we take a look at the types of exploratory data analysis? I'm sure by now your interests are, high. You want to find out more about the domain. You want to start using it practically. We're going to start using it. Don't worry. At the end of this module, before all of that, there is various types of analysis which can be performed using exploratory data analysis. So it is vital that you know all of them. Three important types of exploratory data analysis that exist are univariate analysis, bivariate analysis, and multivariate analysis. Now, what happens with univariate analysis? Uni, as the name suggests, you will be analyzing only one particular variable. You will be using a good amount of data to analyze what is happening to that, that column worth of data, right? And then when you're taking a look at bivariate analysis, with bivariate analysis, as the name itself suggests, you'll be taking a look at two things. You'll be analyzing two variables at the same time to see what is the goal that you're trying to achieve. And then we have multivariate analysis. See, multivariate analysis talks about how you can go on to perform analysis based on more than two variables at a time. So it may be 3, maybe 4, maybe 5, maybe 10, right? So knowing that your result is based on just one column data, 2 columns of data, 10 columns of data, and the results you get out of it is astonishing compared to knowing that, hey, only one row of data can have so much impact, right? That is why it is very important. Now, quickly take a second to see if you can think of an example for univariate and bivariate, right? For multivariate, I can give you a good example. If you're trying to teach a machine learning algorithm to see if it can predict if a person has diabetes or not, diabetes is one of these medical conditions where it depends on a lot of different things. It depends on age, it depends on a factor of hereditary, it depends on your blood sugar, it depends on your body mass index, it depends on if you're obese or not, it depends on your weight, it depends on your height. There are million different variables that can be used to assess and say that this person might be diabetic. For example, your sugar levels, your blood sugar levels can be super high, and that is when you realize that you might have diabetes. Maybe you have a wound which is not healing. That is one of the symptoms of diabetes as well, right? So there's many different things. That is a classic example of multivariate analysis. So you take a second to think about univariate and bivariate analysis. Right. I hope you all did that, because here are some really nice examples for the same. Multivariate analysis we already discussed. You'll be trying to see if diabetes can be predicted, if you have insulin at hand, if you have the age of the person, the body mass index, and all of these things. Next, when you're taking a look at univariate analysis, back to one variable analysis. Here, if you want to understand how the person's age changes, and maybe how the height changed based on the age, right? So when we were all babies, we weren't a lot tall, and as you grow years and years and years, you can go pretty tall, right? 6 feet, 6.5 feet, all of these are achievable. So this change of height is dependent on your age, right? So using one variable to see if the person how the height is changing of this person. So that's an important thing to know. And the next thing is bivariate analysis. See, with bivariate analysis, you're trying to understand variables based on two analytic criteria. For example, if you look at multiple sporting events that happen, right? For example, there's cricket, there's hockey, there is swimming, there's badminton, there's all of these sports. If you want to find out what the population prefers playing, right now, what the males prefer, what the females prefer playing or watching or whatever it is, you will realize that there is a difference between, there's a difference between what people like as well. To understand what they like, you have to take two variables into account and have one sport and say, hey, males usually like playing cricket, maybe females absolutely love playing hockey or badminton, whatever it is, right? That was just an hypothetical example, but that is the case. Next, if you're taking a look at your GRE score, right? Now, maybe with more and more experience, if you prepare for competitive examinations such as GRE and GMAT and all of these examinations, it could come to a point where, with more experience, you can do it better, right? So here again, your score is dependent on your previous performances, your score is dependent on how you learn, and your score is also dependent on your age. So there are two important criteria that you can pick up and perform bivariate analysis, even in a multivariate analysis statement as well, guys. So these are some of the important examples of exploratory data analysis that you guys should know about. And once we talk about all of these examples, we come to a very important step where you have to understand this entity called as box plot. Box plot, again, we're going to discuss all of this in the data visualization module in a good amount of detail, but for now you have to understand that it is very important you know what box plot is, right? For example, if you have concentrated well on the probability module and of course the module number 2, which was statistics, there I have specifically mentioned that you have multiple ways of how you can split the data, work with the data, and all of that. So a box plot is basically a measure. It is a representation of a measure, if I have to put it out accurately, right? Now, if you have a lot of data points and you want to, for example, if you calculate the metrics of, central tendency, it is mean, median, and mode, right? If you look at your box plot right now, your box plot will look something like this, where Q1 median, Q3 min, max, and outliers, all of these are individual values. Each circle you see is a data point, right? So if your data is broken down into its quartile ranges, there are again 4 quartiles which are calculated, right? So there's one quartile in between minimum and Q1, you have another one between Q1 and median, you have another one between median and Q3, and Q3 and max. So we are dividing data into 4 different quarters and working with them, because we'll be taking a look at data as a percentile and all of that, right? So in this case, whatever data we had at hand, the minimum value was maybe 1, the Q1 value, the first quartile value was somewhere around 7, the median was 11 or 12, we had the third quartile value, the Q3, which is somewhere around 25, and then you had a max value in your data which said, hey, the maximum is 30, and then you have something called as outliers. These outliers are concepts which are deviating from the actual data. For example, if you can see that your minimum is 0, maximum is 30, you might have data which is like 100, 150, 200, which are very different compared to the majority of population of data, right? It may be -1, -10, -100 also if you're not expecting that. That is called as an outlier. It may be an anomaly, it may be an error, or it might be those 2 or 3 of the exponentially rare cases which might occur to give you that kind of a result. It is possible. So it is vital that you take a note of where and how all of these elements are represented on a box plot. You have the minimum element on the left hand side, you have the maximum element on the right side. But here you might have outliers on the left or the right also. But again, when you take a look at the divisions, there is a quartile between min and Q1, between Q1 and median, median and Q3, and Q3 and max. So whatever is the values that fall there, it is a part of that quartile in data, ladies and gentlemen. So it's a very important thing that you understand this. And the next thing that we're taking a look at, as I've mentioned in the session takeaway for this particular module, is the advantages of EDA. There are numerous amount of advantages. I can just have a 1 hour session just to talk about the advantages of EDA, but I want to give you a good amount of highlights to tell you what they are, right? Now, advantages are many, but the most important reason why exploratory data analysis is even so popular is because of the fact that you can, look at data, understand that, hey, I want to use this data to get to this point. Can I do it or not? If the answer to that is yes, just start digging into the data, hunting for conclusions, looking for insights which your data can give you. A good example to this is maybe you are a person who sells chocolates and cakes and all of these, right? Usually during Christmas and New Year, this sells a lot. So in that particular case, what usually happens is, you will have to stock a lot of these items, right? You will have to, maybe in the month of November, if you sell 100 chocolates, in the month of December you might sell 1,000. So you have to have previous year's data. If you look at maybe 2019 or 2020's New Year data, there might have been 800 people, 850 people who have bought it, right? So in that case, that's not an outlier. You use that data to know, hey, the analysis result is that in the month of December, I am selling a lot more chocolates that I am actually producing, or whatever it is. So arriving at data-driven conclusion, it's not a guess, it's a conclusion, and it is proven by data, right? So that's an important thing you should know about. The second thing is that whenever you're taking a look at all of these things that you can do with exploratory data analysis, one thing which is usually extremely popular in today's world is that you'll be checking out for data anomalies and the consistency of data itself to know if your data is correct or not, to know if your data is doing what it is supposed to do and that it is not hurting any other pipeline down the line. It becomes very, very vital that you understand data anomalies, ladies and gentlemen. So that's that. And the third thing is feature engineering, right? So feature engineering is one of these concepts where you'll try to understand what feature can be used to obtain what result, or if you can explore into finding a feature in a way where, maybe there is another concept in the case of diabetes, right? There is another element that we are not looking at, which can have an impact on your eventual goal of a person being diabetic or not, right? To analyze that, there might be some other feature. We are considering blood sugar, body mass index, age, weight, all of these things, amazing. But it is not that is the entire thing, right? There might be something else, and that something else to find out is exactly what you're going to be taking a look at with feature engineering. So I hope you have concentrated on the second point, because the fourth point talks about something similar, which is data pre-processing and cleaning. Again, over the last couple of modules, you already know this. I have stressed how much is the importance of data pre-processing, data cleaning, and making sure that you feed the right amount of data to your process of how you would analyze data, or of course to a machine learning algorithm. You have to be extremely careful if you're giving the data to a machine learning algorithm to learn, because it can go wrong in so many different ways that I've mentioned in the last module, right? If you show a picture of a cat and a picture of a dog, if your computer is trained wrong, if your machine learning algorithm is trained wrong, it can interchange and see a picture of a cat and say, hey, that's a dog, and I'm sure. And it can see a cat and say again that, I'm a dog. So it doesn't make sense. And I gave you a very simple example, but in an actual productive environment, this can get, very, very, very difficult to handle. And people will not know what's going wrong, where it's going wrong. But at the end of the day, it usually comes down to the quality and the quantity of data too. So it's important. Next advantage here is that with exploratory data analysis, you can have the capability to handle these two concepts called as underfitting and overfitting. Now, underfitting is one of these concepts where your machine learning algorithm does not have enough access to data. It is not searching your data enough where it is getting some meaningful learning done. So it is just brushing through things. It is not understanding things in detail and all of that. That is underfitting. Overfitting is the exact opposite of it. It is when it completely starts looking into your depths of data. It is looking at noise rather than useful information. It is using this noise to learn, which at the end of the day will hurt its accuracy when it is overfitted, right? So handling underfitting and overfitting becomes extremely important, because if you do not do so, again, your data is messed up when you process it ahead, because not only will your values, the output values that you might get can be wrong, but it also comes down to a fact where your machine learning algorithms processing itself is going to take a lot more time. It's going to take a lot more time to learn, and eventually, even after it does that, the accuracy is not great. So it's not a win-win situation in any way possible. So it is very vital to handle underfitting and overfitting in any of these solutions, and EDA is doing a very good job at helping for that. Right, so guys, in the next section, we are going to be taking a look at all the concepts of EDA in a practical fashion. Now that you already know all the basics, right, it will add a lot of value if you learn things practically, and I'm going to do my best to do the same. Now, what happens in the case of EDA is this, especially in this data set that we're taking, is a really fun data set to take out. So I hope that we do have viewers here who are fans of cricket, right? Now IPL is Indian Premier League, which takes place on a yearly basis, where it is a very popular event here in India. It's a cricketing event, and there's a lot of insight which even the teams are very keen to take a look at the data to understand what was the bowler's performance, batsman's performance, who plays really well against which bowler, which batsman. There's a million things that these guys will be analyzing and looking at. They will have entire data analytics teams together who are sitting to analyze individual players. So that is how much how much complex sport has become these days. They try to predict things, they understand strategies, they try to get strategies from an AI related algorithm as well. There's so many different things that they're doing. So we are going to use this data set which has all the data regarding the Indian Premier League, which has happened over the last couple of years. So there are certain questions which you can ask, right? See, exploratory data analysis is you exploring. For you to explore, you must ask some questions and get answers from your data, right? There are certain data set questions that you can ask. For example, saying, what is the size of the data set that I'm dealing with? Well, you can find that out in Python. Next, what is the type of data that we're trying to work with in this particular data set, right? There's numerous types of data which one is working with. Here in IPL data, again, I'm going to show you all of these things practically, but of course, it's not just IPL data that we're talking about here. It is you asking a question saying, what are the types of data I'm working with? Can I find it out and can I use it in the next couple of steps? The answer is yes, and you can find out the types as well, right? The next thing, dataset question, which is very important to ask is the data pre-processed, right? To find out data cleaning. Remember when we spoke about advantages, I told you that it helps in pre-processing as well. This is exactly what we're talking about here. These are all dataset related questions in a way where you can ask if the labels are correctly present to the data as well. For example, if you consider a player, if he is just a batsman and not a bowler at all, right? So in that case, if your data is correctly put him as a batsman rather than a bowler or any other thing, right? It might have put your captain as a coach or something like that. There will be something wrong with the data in many cases. So here is where you ask these questions to clear out that air. The next questions, the set of questions that you're going to be asking is statistical questions, right? In the case of statistical questions, you'll be asking so many things to your data saying, hey, so what are the values of central tendency? How is the quartile division of the chart? You remember I showed you the box plot which contained Q1 median, Q2 min, max, all of these values. The box plot itself is a representation of the quartile division. Your values will be shown. You can do that with the help of EDA. And then when you're taking a look at the third thing, right? The third third thing talks about how important is it for you to understand the total count of all of the individual data elements that are present, knowing that you'll be using 10 rows worth of data, 10 columns worth of data to at the end of the day take your result and show that, hey, my result is backed up with this amount of data, right? That's a very important question that you are going to be exploring. So guys, without further ado, let me quickly jump in to Google Colab. Again, we have used Google Colab previously. However, let me zoom in so that it is better visible on all of your screens. This should be perfect, I presume. So we're going to be taking a look at exploratory data analysis on the IPL data set. But before all of that, I have to upload the data set. So let me quickly go on to upload the data set. As soon as I hit OK, if this orange circle vanishes, it means the data set is uploaded. Perfect. I can close that, and we are here. Guys, the first important thing that you have to take a look at is, as you've already checked out in the case of machine learning and all the other modules, what is the first thing that we do whenever we are working with any program? We import all the libraries and the dependencies, right? So for this particular case, to perform exploratory data analysis here, we require pandas, first of all, to store the data as data frames. We require NumPy to make sure we're working with numerical computations using its data structures as well. And we're going to be using Matplotlib and Seaborn. These are two beautiful data visualization libraries, which I absolutely love working with. We're going to be checking out data visualization itself, ahead in the next modules. But then for now, you have to know that we are going to be using it, right? So as soon as I hit the play button, these libraries are all imported and ready. The next step after importing all your libraries is to bring in your data set to the working environment. In this case, the working environment is the IPL data set, which we have to bring into our Google Colab. So as soon as I go on to click this, we are using read_CSV method in pandas to take a look at our data set. Right now, let me quickly zoom out a little so that you can see the data better. Right, so I've basically printed the first 5 rows worth of data using data.head. I can print 10 as well. It's a pretty simple thing. All I have to do is pass 10 as a parameter to it, and instead of 5, I now have 10. Amazing, right? So the data that we have is something like this. There are identifications for the data rows. Eventually then, you're taking a look at all the various cities where the games were actually played, where the matches were actually played. Then you're taking a look at the dates of when individual matches were played, who are the two teams who played these matches, who won the toss, what was the decision after they won the toss, what was the result, was the match forfeited, was the match won, match lost, who was the winner, who won by how many runs, and there are so many things. Let me scroll to the right. You can find out by how many runs they won, how many wickets they won, who was man of the match or player of the match, where was this game played, which venue, who were the first umpires, second umpires, and third umpires as well, right? So this data set is beautiful to work with. It will give you a lot of insight when you're working with, ladies and gentlemen. So to move ahead, we have to next take a look at how big is our data set. I just printed 10 rows for you, right? So with data.shape, we will come to a realization that we're using 18 columns of data, and each of these columns have 756 rows of data. So overall, we have details about 756 IPL matches. We're going to be using that to analyze things, right? So guys, it's very important you know that this is not only data from one single IPL season, but this is data from multiple IPL seasons, right? So we're going to check out all those seasons as well. So when I go on to click data.info, it will show you just all the details about this itself. Data.shape just gives you it in a concise way, but if you want more details about it, as I told you, we have 18 columns worth of data, 756 rows of data, and it will show you samples of what these data is as well. See, for example, some cases your umpire number 2 or umpire number 3 is NaN. NaN means not a number. It means that data is not present there. So you do not have the name of umpire number 3 for a particular match. And for our case, it is okay. But maybe if you're trying to analyze the performance of the umpire himself or herself, then in that case, it becomes tough, right? So it's very vital that you print out to realize this. Next, let me just print out all the columns that we are trying to use. ID, which season, IPL season, which city was it, what was the match hosted, what is the date, two teams which played, who won the toss, what was the decision, what was the result, so basically everything that I ran you through, right? So all the columns and the labels are very, very important stuff. Next thing when we talk about is finding out if there are any NaN values where there are not supposed to be, right? See, for example, seasons are all these year dates, right? IPL 2016, IPL 2017, 18, all of these things. So these are numbers, so there are no NaN values. Then city. City is not a number. You cannot say Bangalore is 1, Hyderabad is 2 and all of that. There you have to give a name. Bangalore is Bangalore. Next, Hyderabad is Hyderabad, right? So city name is will be a character. Then you take a look at a lot of things which are false, because all of these are number outputs, but wherever it says true, it is trying to give you a character output, right? Now the name of the team who won a cricket match will not be a number. It'll maybe be that, hey, this team won by that many runs or wickets, but which team won? The answer to that question is a character or a string, right? So that's the reason why this is true, and it is true for all the umpires, because all of these are just names of people, right? Even man of the match or player of the match. I hope this aspect of it is clear to you. The next thing we're going to take a look at is to describe the data in a standard way where we understand using statistical functions. So data.describe will eventually give you a lot of different things. First of all is the count of how many rows worth of data is there. We have 756 match data. What is the mean of all the IDs? You can find the mean of all the average win by runs in all 756 matches. You can find the standard deviation of how far the data deviates from the mean. You can find the minimum value, minimum number of matches played, minimum number of matches won by using runs. Maybe the team won, there was a draw, then there is no winners, right? Then you're taking a look here at min, 25, 50%, 75 percentile and max, right? So this is the interquartile range. It's called as the quartiles. Interquartile range is when you perform a calculation on it, but this is the quartile range that you're printing out. This data falls upon and in between that quartile. So that's an important thing that you are supposed to know about, right? So that's important. The next thing is we start asking questions on the data set, if you remember. And one important question that we're going to ask is how many matches were played in total with all the data set, which we already know this from because I showed you the data set previously. We are 756 matches worth of data out here, right? So that's something which you have to know. The next thing is we'll try to see how many seasons are we trying to analyze. Here all we're trying to do is we're finding the seasons columns, and since there is 756 matches, you can get 756 answers here saying IPL 2018, 19, 19, 19, 18, 17. So all of these things. So we're trying to use the unique method here to only print us all the unique data. So this data set consists of data right from IPL 2008 all the way till IPL 2019. Again, this may be accurate to what happened in real life, or this can be a hypothetical data set. We are going to assume that it happened in real life, so we can just have more fun with the data set, but that is how it should be as well. This is a hypothetical example of using the data set, guys. So the next question that we can ask with that particular data is which IPL team won by scoring the maximum amount of runs. So which team won a cricket match where they scored the maximum amount of runs, right? So as soon as ILOC is basically us using a filter we're trying to apply on the data where we're trying to find the max element that is present in that particular column. So as soon as I run this, it will tell us that, hey, it was basically IPL 2017. The match was played in Delhi. Here's the date of the match. It was played in between Mumbai Indians and Delhi Daredevils. Delhi Daredevils won the toss. They wanted to field. The result was normal. It was just win or not win. Mumbai Indians won and they hit 146 runs, which eventually gave them the win, right? So maybe the other team could not chase that amount and they were bowled out or whatever it is, right? So these guys won by 146 runs in an advantage. You have man of the match, LMP Simmons. You have the venue. It was played in Feroz Shah Kotla, right? Feroz Shah Kotla, I think, is in Delhi. I don't watch much of cricket, but I hope that's the case. Look at this. One line of code, it is very simple line of code. All you're trying to do is find the maximum in a column and you have such beautiful insights to take a look at it, right? Next, the next question you're going to ask is, okay, so who won by, just taking down and destroying all the wickets? So which team won maximum that way, right? So this is again IPL 2017. The match took place in Rajkot between KKR and Gujarat Lions. KKR won the toss. They wanted to field and KKR eventually won the match because because they bowled out every single one of Gujarat Lions's batsmen or something like that. Again, I do not know if this data is true or not, but as of what I can see with my data set, the question I asked, I have the answer right in front of me, right? So it was played in Saurashtra Cricket Association Stadium, which again is in Rajkot, I believe, right? Again, you have details about the umpires and all of that as well. They took 10 wickets, which is again the maximum number of wickets you can take to win. Right. The next question, we can go on to ask is, which IPL team won by taking minimum wickets, where they might have not made the batsman out, but eventually their bowling was so good that they never let the opposition score runs, right? So this was a match in between Sunrisers Hyderabad and Royal Challengers Bangalore, SRH and RCB as they are called. RCB won the toss, they wanted to field, and Sunrisers Hyderabad won this match. They won it by 35 runs. This is the minimum amount of this is the runs that they did, but the minimum amount of wickets that they took was 0. So even though no wickets fell, their bowling only gave RCB chance to hit 35 wickets or something like that, right? So this match was played in Hyderabad. It was played in Rajiv Gandhi International Stadium, Uppal, right? See how nice, how fantastically you're getting answers to your data here. That is what makes EDA so much fun. Next, when we are taking a look at which season consisted of the highest number of matches ever played from 2008 to 2019, here's a beautiful graph that we are trying to print for you and showcase the same, right? So we have data IPL 2008, 9, 10, 11, all the way until 16. We have 17 here on the left, 18 and 19. So as soon as I look at it, I wouldn't have to struggle anything at all. I can see that in the year 2013, the graph is at its highest, which means the maximum number of cricket matches were played in IPL 2013. It was somewhere around 75 matches or 80 matches, around that, right? So it took me 1 second to look at that data and give you the output. Next, when we take a look at which is the most successful IPL team with the data that we have at hand here, again, all of this is based on the data. I do not know if this data is true to its real life form, right? So here it shows that, Mumbai Indians have been the team which has won all of these seasons. They have won maximum number of matches till now. If you take a look at 768 matches, if you ask a question saying, okay, so who won maximum, and can you arrange that in descending order, that is exactly what we've done. Below MI, you have CSK with Chennai Super Kings, you have KKR, RCB, Kings 11 Punjab, and all of these guys who have won smaller and smaller amount of matches compared to the number one person on this list, who is Mumbai Indians, right? Again, it took 2 lines of code. All we're trying to find is the count of the matches that they've ever won. Take a bar plot and arrange it in descending order, and it is literally it, right? So see how much fun is EDA to work with, guys. The next thing we're going to take a look at is a very interesting concept. This usually happens when you play cricket, or when I see the kids on my street play cricket as well. They think that if they win a toss, there is a huge advantage to win a match. It may or may not be the case based on the pitch, based on the stadium, or whatever it is, or I do not know, right? In that particular case, we have to see what is the probability that a match was won if the toss was won. Conditional probability, right? So let's take a look at that. So it so happened in 393 cases that when the toss was won, the match also was won. But in many cases where the toss was not won, or it was either, basically the match was not won even though the toss was won. That is what false says. True talks about how the match was won because of if the toss was won as well. So if I go on to neatly print it, instead of just showing you this, if I print it nicely on a graph like this, if I plot it and say, hey, it is true in how many cases? It is true in 393 cases that the toss helped people win, or it is also true that in 363 of these matches that even though a person might not have won the toss, that they might have won the game or something like that, right? So that's an important thing you have to realize. Right, now basically with this line of code, all I'm trying to do is print more number of rows rather than just 1 or 2 rows. You're going to see what I mean by that. So we have to find out now is the highest number of wins per team per season, right? So as soon as I go on to run this, it will give me an output right from the first season, arranging it in a descending order, telling me who are the people who won those seasons, right? So see, in 2008, Rajasthan Royals won 13 matches, Punjab won 10, Chennai won 9. All of these in IPL 2009, Delhi won the maximum runs in 10, Mumbai Indians won 11, CSK won 12, KKR won 13. So you can see, so if I had not done this higher row width, it would just give me 2 or 3 rows and say it's done. Now I have access to the entirety of the data, and that is the thing that I've said here. I've said, hey, even if I have 10,000 rows of data, you please print it. Even though I have 400 columns of data, you please print it, right? That is exactly what I am doing here, and you can see who won maximum number of matches in that particular season of IPL. Right, guys. So the next thing that I am going to print is to find out what is the toss decision which happened over all of these years. What is the, see, tossing a coin in probability, as you checked out, is it has probability and randomness associated with it, right? So in the 700 and whatever times we tossed a coin, the umpire tossed a coin, 463 times people chose to field and 293 times captains chose to bat first, right? So this shows that maybe if you field first, there is a good chance that you might win, you might analyze the opponent better or something like that, right? So that's an important concept. The next thing we're going to take a look at is who is the person who has won player of the match or man of the match in one matches, of course. So as of what I know in cricket, once you win a match, from the winning team, there is one person who is selected who becomes a man of the match. In basketball, it's usually called as MVP or the most valued player for a season or something like that. But here again, take a look at it. Highest to lowest is what we are printing, right? Let me quickly scroll up since it's printed the entire thing. So Chris Gale, Christopher Henry Gale, I've been to a match where I've seen this person hit a 6 and, I sort of caught the ball. I mean, that's a different story. So here basically this person has hit, has a record of having 21 man of the matches award. Then you have AB de Villiers who has 20. Then you have RG Sharma who has 17, MS Dhoni with 17, Warner with 17. All of these data, again, I do not know if they're correct or not, but as per my data, as per the questions I'm asking, I am receiving beautiful answers, right? So that is what adds meaning to all of these data, guys, right? And the last thing that we're going to check out is to find out where, in which city were the maximum number of IPL matches ever played. So as soon as I got to hit this, all I'm trying to do is find out find out the count of individual cities, find the maximum of it, arrange it in descending order, and my answer is there, right? So there are 101 matches which took place in Mumbai, Kolkata, Delhi, Bangalore. So these top 5 places have been extremely popular from IPL 2008 all the way to IPL 2019, guys. So this is basically telling you that there is, why are people preferring to play in Mumbai? Is it because of the matches? Is it because of how later down the line people started dropping off from the tables? Whatever it is, right? You can analyze 10 different things with one result such as this. This is the beauty of EDA, guys. So this is how we can go on to work with exploratory data analysis. It is a very simple IPL data set that we worked with, but when things get complex, you can go on to learn more and more and more, and it is so much fun that if you ask a question, you can look at your data and pick up an answer by processing something in that data, right? That is what makes EDA so much fun to work with. It is, I'm trying to portray it in a way where it's fun to work with because you guys are getting started with it, but understand this, it is extremely powerful. It is used by individuals. And right, guys, let's get started right now, right? So introduction to data visualization. Ask yourself the first question here. Why do you think data visualization is even required? Next, we're going to talk about data science, right? See, why it is required is a section on its own, but as I've mentioned, the result of a data science output in be it any domain, machine learning, deep learning, or any kind of a subdomain in the case of data science as well, the result that you obtain will not be understood by a non-technical audience generally, right? You have a complex data set which has 10 lakh entries into it, or you have a result which only is understood by a person who knows Python, who knows machine learning, who knows deep learning and all of these. Right? Now, when you're working in an office, do you think everyone around you is a machine learning expert or a deep learning expert? The answer is no, right? Sometimes you have to take the solution to a client who will not know deep learning, or you have to take it to your stakeholders, your managers, your board members, and explain to them in a way that they understand this complex data, right? So you as a person should have the capability to take something really complex, textual data and convert it into beautiful looking visualizations, guys. And in fact, even here are some really fun things that you should know. The first thing is human beings, right? As human beings, we can comprehend and understand an image 3,000 times faster than reading text. How amazing is this? Now, this is one of the primary reasons why the film industry took off rapidly, way back, centuries back. But at the same time, you definitely have to know, you definitely have to understand the meaning, the impact it has, right? If you can convey something 3,000 times faster, why would you not want to do it? Makes sense, right? Exactly my point here. The second point is that, as I mentioned, your data, your output, or wherever it is that you have to explain, whatever point of execution, it will not be understood by a person who might not know machine learning or deep learning. In that case, it becomes your duty to make sure you convey the information in a way which they understand, right? This is where data visualization comes into, the most important sector of data science itself. It so happens that even in real life situations where maybe you're looking at a sales team and the sales team is getting some data from an artificial intelligence model or a machine learning model, if you just send the output as it is, there's a good chance. Sales guys are amazing at sales, but I'm not sure if they're really well versed with machine learning. So it is my job to make sure that my machine learning model or deep learning model is presenting an output that is understandable and comprehensible by the sales team, right? That is one example where even in real life, everywhere around you, it does happen. It is not only just this example, there is hundreds and hundreds of examples, right? So eventually, if we are coming to have a discussion about the definition itself, what data visualization is and all of that, you have to understand that this is a structured process that we use to take input as our textual data, numerical data, character data, string data, whatever it is. We take all of these data to see if we can create graphs out of it, which are not only aesthetical, right? So graphs can be very boring to look at, or they can be very amazing with all colors, points, markers, and all of that, right? It is not only the aesthetics aspect of a graph that we look at in data visualization, but also the functional aspect of it. How good does it look and how well does it work? These two questions you always have to keep in mind when you're working for a data visualization solution, right? So if you have one graph, it's one solution. It could be that one graph is enough to, gather all, compress all of this data and give one concise picture. Sometimes you would need more than one graph. If you require more than one graph, it is usually called as a report, where a report consists all of these graphs and there are descriptions of each of these graphs, what they mean, what is the takeaway from them, and all of that, right? So it becomes very vital that you know how to take these reports, and eventually sometimes you have to put it out on an online media, right? Sometimes you have to put it on a website, a web application, and whatnot. So it becomes key that you create a dashboard. Now a dashboard is basically a website where you can see all of these graphs, and sometimes in the case of business intelligence solutions like we discussed previously, right, if your data is changing, your graphs can be changing in real time as well. That is the beauty of data visualization, and especially in the world of neural networks and the world of deep learning, where you want to track what's happening to your own program or code, sometimes with the help of graphs, right, it is very, very vital. It helps a lot immensely to rather not see just volumes of data and rather see a good amount of graphs where you can understand everything without having to spend hours and hours breaking your head about it, right? This is the importance of data visualization. But does it end at that? Is it only 2 or 3 reasons why data visualization has been so popular? The answer to that is no, because at the end of the day, it will give you multiple things which you thought which was not possible from a graph. Now, as you look at a graph, you can say, oh, okay, so my data said this is what the output is, we are done. No. It helps to map cause-effect relationships, right? Now, I'll give you an example which we've already discussed previously, right? So how do you predict the weather? Previously, if you went back 300 years or 200 years, to predict the weather, you would have to go outside, look up at the sky. If it's dark, if it's black, if it's full of, clouds which are like really dark in color, it means that there might be rain, snow, hailstorm, or whatever it is. If there was a blue sky, very clear sky, it's a hot day, there's absolutely no cloud in the sky, it would not rain as much, right? So a cause and an effect relationship are built here. The cause is that the clouds it themselves will cause the rain becomes the effect. To see if it rains or not on a particular day, you can use this cause and effect relationship to derive another cause and effect relationship between day and rain instead of cloud and rain, and eventually you can build relationships like this, which will give you a lot of insight, a lot of depth, right? So just convoluted layer inside layer, and the amount of insight you get is amazing out of it. Right. The next thing we're talking about is feature engineering. See, sometimes when you go on to visualize graphs, you will realize at the end, looking at the graph, saying, "Oh, okay, so if these three, variables are pointing out in a multivariate analysis situation, they're having a good impact on my output variable. What about a fourth one? What about a fifth one?" So this kind of a feature engineering thought, looking at more than, more amount of features that can add in value to your program, which you thought might not be possible, will definitely become possible if you explore the usage of data visualization in that regard, right? So you might be asking, is that it? The answer is no, because take a look at the third point. It helps in finding and mapping and removing outliers in the data. Now, I've already spoken about pre-processing multiple times in this full course video, but it so happens in many cases that sometimes there are outliers which you cannot see in a huge data set even with pre-processing methodologies. So there you might have to plot all of those on a graph and then work on removing those, because there you can visually see it, where all of your data are one side, but you definitely have points on the outside. So those are the outliers, right? So you decide if it's an outlier or not and eventually push out those values. If you do not, it'll be detrimental to your machine learning model, which will eventually learn things wrong and give you a wrong output, right? I've discussed this already. Next, the fourth point. The fourth point makes sure that your data is understood by a non-technical audience. We just discussed this, and this is a very important point. I want to emphasize on all of this because I do get asked a lot saying, is it that important that you have to make everyone understand your data? Everyone is subjective, but a non-technical audience understanding your data is very important, because if the client himself was a deep learning expert, why do you think he would come to you for work, right? So that is one thing that you always have to keep in consideration, guys. Now, the thing that we have to understand, a very, very important aspect here, is that there are multiple, data visualization libraries out there in Python and of course in other programming languages like R as well. But since we are championing Python here, and of course the entire world is championing Python for data science, I want you guys to understand the top data visualization libraries that exist. And again, if you already know this, take a second, pause the video, note them down, or of course put them down in the comment section saying that you know all of these. It'll just add a lot of value to your learning, and it just makes learning fun, right? So that we know what you guys know as well. So make sure to do that. And then of course, when you're resuming the video, here are the top 3 data visualization libraries which are extremely important in Python, guys. Now you might ask a question saying, okay Anirudh, so is this the only 3 Python data visualization libraries out there? The answer to that is an absolute no, because with Python, since it's open source, even you can create a data visualization library on your own if you choose to. But these are what you see, right? Matplotlib, Seaborn, Plotly, all of these are sort of intertwined with each other in a way where it gives you the complete functionality which you would require in creating a good data visualization. Not just one graph. If you want 100 graphs, you can do it. If you want 100 different graphs with 100 different styles, and for it to be equally functional and understandable by a non-technical audience, it can be done with these 3 visualizations: Matplotlib, Seaborn, and Plotly. And across the world, if you look at trends, there are numerous reasons why each of these libraries are considered. They are the best at what they do. The developers have put in a lot of time and effort to make sure that when you use this library, it is easier for you, to do it. So eventually it adds a lot of value to your learning, guys. So let's quickly check out Matplotlib. Among Matplotlib, Seaborn, and Plotly, Matplotlib is considered to be the world's #1 data visualization library if you're using Python. So it works in a variety of situations. That's the beauty of it. Do you want to use it in Python script? When you're scripting manually, if you want to use it, perfect, it works. Are you using any sort of shell command interfaces where you want to, again, print certain graphs? It works there as well. Do you want to use Jupyter notebooks like how we've been doing for a while now? Of course, it does work in a Jupyter notebook. If it works in a script and a shell, there's a good chance it works in a notebook, right? So that is an important thing. This kind of a diversity, helps you learn it in an effective way. The next thing is that when you are thinking about the graphs, the different types, the different varieties of graphs and charts and whatnot that you can put out with Matplotlib, the collection is absolutely huge. The literal number of, graphs that you can put out, the types of graphs are amazing, and each of them are very good at a single purpose, right? So you open up your dimension to a wide variety of, requirements that you can cater to in a very simple fashion. And the third thing is that whenever you're talking about graphics, whenever you're talking about creating an image or anything of that sort, the first question a technical person is going to ask is, okay, so how much of memory and processing power am I going to require to do this, right? Printing textual information will take certain memory, no doubt about that, but printing an image, printing a graphical entity will take exponentially more. So in this case, though, depending on how well Matplotlib is designed currently, it is actually very, very efficient in terms of memory. It is very good for processing power, and even if you can get away by using Matplotlib on a low power computing machine, which again, it will work absolutely fine. It might take a second or two to execute, but at the end of the day, it will work. That is the advantage. You do not require a really fancy, expensive system to run these visualizations, right? And the next thing we're going to check out is Seaborn. Guess what? Seaborn is a library on its own which is eventually built on top of Matplotlib. So it extends the functionality of Matplotlib if you require a lot more functionality than what Matplotlib can offer natively, right? At the end of the day, Seaborn's primary reason for being another amazing graphic library here or a data visualization library here is that it can be used with a high level interface whenever you're plotting any sort of statistical graphs and all of those sort. So doing this will make sure your job as a person in visualization becomes easy, and at the end of the day you have a good amount of time working on your logic or whatever it is, rather than breaking your head about data visualization, right? Okay, next, the second point. The second point talks about how Seaborn works amazingly well with data from NumPy and Pandas, right? Now, we've already discussed NumPy and Pandas to a good amount of detail using this data. Now, once you have NumPy and Pandas data, you cannot say, hey, my visualization library does not support that, so let's convert it into something else. All of that is not there here. As it is, whatever data is thrown out by NumPy and whatever is the data structures, series and data frames, whatever it is, with the Seaborn library, there's a good chance that you can directly use it without having to manipulate it a lot. This again saves time and efficiency, right? Of course, when you're taking a look at the third point talks about how you can plot certain functions over your data. You can work with your data set effectively. In many cases, using and learning with all of these data sets becomes easy if your library makes it even more simpler than a generic solution, right? So that is how Seaborn actually works. It simplifies an already simple solution to make sure that you guys can learn it all quickly and work with it effectively, right? Okay. Now, the third one that we're going to talk about is Plotly. Plotly is basically a web-based toolkit that is very, very popular, again in the case for data visualization. It has three very important points that you should know at this moment in time. The first point is that it provides amazing APIs to work with. This makes sure that you can tie in your program here, get the result out of it without having to break your head about interfacing these two entities, right? The Plotly library and whatever it is that you're trying to visualize. So the second thing here that you definitely have to think about is how there are supports given for 3D visualization and 3D plots. 3D visualization and 3D plots just take data visualization into a whole nother level. But until you get to a good amount of complexity, there's a good chance that you guys might not be using it. So eventually overwhelming yourself with a 3D visualization as of now is definitely not recommended. But what you should be knowing is that with Plotly, you definitely can do it. Even with Matplotlib and Seaborn to a certain extent, you can work with a couple of plots to make sure it looks like 3 dimensions or it has 3 dimensions itself. And in a concept called as contour plots are these entities which are notoriously difficult to map, but the results they give is very beautiful to look at and highly functional. Those can be used here as well. I just gave you one example. There are many things that Plotly can do better than Seaborn. There are many things that Seaborn can do better than Plotly and Matplotlib, and of course Matplotlib in its own nature can do multiple things better than all the other two as well. So that's an important thing, you guys should know as well. Now, we are coming on to a section where we will be discussing the important visualizations that exist in the field of data science, right? There are hundreds of visualizations that you can put out if you're looking to the extreme depths of it. But out of those 100, 5 or 6 or maximum 10 of them are extremely popular in a way that you definitely have to know all of these guys. So I recommend you have a pen and paper ready so you can take down certain important points of all of these. And after we go on to discuss this, right, we definitely are going to check them out practically so that you know what we are dealing with as well. So theoretical learning plus practical learning is what we here at Great Learning stand for, and of course we're gonna take it that way to make sure you guys can learn it in a simple fashion. Right, now to talk about the important visualizations for data science, there are so many as I mentioned, but I want to discuss 6 important visualizations with you. So we have bar plots, we have the pie charts, we have histograms, box plots, scatter plots, and of course the strip plot as well. So these 6 are the ones that we're going to be checking out theoretically and practically, guys. Now, wait, let me actually go back before we discuss bar plots. Tell me if you have actually worked with any other visualization. It doesn't have to be in Python. There's a good chance that you might have used a pie chart in your school or college or sometime then, right? Histogram is very familiar for photographers because again, while editing it, that becomes a very important component. Box plots is used for statistics. We checked this out in the previous module. I want to revisit it again because it's important. Scatter plot and strip plots again give you a beautiful looking visualization, yet so much data with it as well. So guys, if you know any other visualization which you think are important, head to the comment section and do put it down there so we know again what you are looking towards as well. Right guys, now taking a look at bar plots, right? See, bar plots, as you can see on your screen on the right side right now, is what a bar plot looks like. It is a very beautifully aesthetically pleasing entity. You can select all the colors, you can work with multiple things, and it is mostly used in a case where we have to, show that there are certain numerical changes whenever we compare it to categorical labels, right? See, a categorical label can be something such as height of a person when you're taking a look at age, right? You can put a student's name, for example, and map their particular age as well. Or consider the age of common students, like maybe just take the case of class 10 students, try to map the age of all of these, right? So there is a categorical element being that there are people from class 10 and the numerical value here is the age that you're going to map, right? It can be height, it can be age, it can be weight, it can be roll number, whatever it is that you want to do. Bar plots will definitely help you get there. Right now, even looking at a certain data like this, you can just say, hey, here's the height, weight and age of 3 different people. So using that, you definitely can show, the gray color is one person, yellow color is the other person, blue is another person. Of course, you can have 100 different persons if you choose to, but yes, that kind of a feature will make sure that, instead of just looking at an Excel sheet with like 1,000 students with all the data of their age, height and weight and all of that, if you were to look at a graph like this, you can definitely pick it up rapidly and say, oh, okay, so this is the average height, this is the tallest person, who's the shortest person, who weighs the most, who weighs the least. If that is the kind of information that you're looking at, you definitely can get access to that with bar plots. Right. Next thing we're going to check out is pie charts. Pie charts are something I definitely remember learning in my school days way back, a couple of decades ago for sure, is that this is a kind of a thing that will show you there are certain divisions, right? An entire pie chart is consisting of 100% of the entity that we are in discussion. But when you take a look at a fraction of things that you have to discuss, pie charts are an amazing way to do it. Here again, we'll be comparing numerical values and categorical values and all of that. And see, for example, on your screen right now, you can see 3 numbers, 40, 40, 20. When you add all of that, you get to 100%, right? So that is showing the entire completion in one circle. But in those circles, each color shows a representation which has a categorical label given to it, right? Now, for example, Think about a situation where 40% of the people like pizza, another 40% of the people like eating fries maybe as an evening snack or something, and then there were 20% of people who like to maybe get a fizzy drink or get a soda or something like that, right? When you think about evening snacks, now these are just random things that I just told you. It will apply to any different situation. If you want to think about pizza, now I'm hungry thinking about pizza, right? You can just say that there are three people and this is how much pizza each person ate. Two people ate 40% of pizza, and there was another person who ate 2 slices out of 10 or whatever it is, right? So you can find any sort of situations where you have to divide in fractions, and you can represent that easily in the case of a pie chart. That is the beauty of using a pie chart, guys. So after bar plot and pie chart, the next thing that we're going to check out is histograms. Histograms are extremely important in the case of data science because here, whenever we're trying to assess what a continuous group of variables are doing or values are doing, and we want to see their performance, their changes, or why assess why they're changing the way they are, what is the result of these continuous variables changing, all of these, right? You can find out easily with the case of an histogram. When you're using an histogram, usually data is in the range 0 to 255, 1 to 300, minus 500 to plus 500. So this kind of a range makes sure that your histogram doesn't go out of bounds and that it works effectively, and the visualization that you get at the end of the day will add meaning rather than confuse you, right? That's an important thing. So talking about an example for an histogram, maybe think about how you can categorize people based on their age. Again, you can do it with a bar plot again, but at the end of the day, it's vital that you understand how you can do it with an histogram too, and knowing that you can do it is the first important point, guys. So you can think about any other example where you would want to map a continuous value. For example, if you want to map the changes of cost of fossil fuels, maybe the change in the price of petroleum, diesel, or whatever that is. Again, that's a popular usage of histogram that I have actually seen in petrol bunks near my place. They put up a chart to show that either the price went up, price went down, whatever that is, and all of these, right? So this is histogram. The next thing we're going to check out is box plot. Box plot is this very simple box with two lines that packs so much of an impact. It gives you a ton of information, which is, again, when you look at it as it is, you'll be like, okay, so what is it? But once you understand what a box plot means, like I've explained in the previous module, you definitely will know that it is just an expansive amount of wealth of information that you're going to get out of it, right? Now, as you can see, every single point here will talk about a data entity. For example, min talks about the minimum value you have in your data set, max talks about the maximum value, and of course you might have outliers on both sides of the data as well. It can go below the minimum, it can go above the maximum and whatnot. And then you have three important points: Q1, median, and Q3, right? So minimum to Q1 is the first quartile, Q1 to median is the second quartile, median to Q3 is the third quartile, and of course Q3 to the maximum value becomes the fourth quartile. And wherever you see this center, and of course all of these are not labeled all the time, there is numbers given in that particular case. In this, the minimum may be 1, the Q1 may be 5, median is somewhere around 11 or 12, Q3 can be somewhere around 25, maximum is 30. All these outliers can be 33, 34, 35, which you think make no sense with your data, right? So it's a simple thing, but once you understand it, you'll get to know everything: minimum, maximum, medium, the quartile range, and all of that. Once you have the min, max, Q1, median, and Q3, you can find out the interquartile range as well, and you can start reverse engineering statistics out of a chart as well. That's the beauty of box plot. So guys, it is vital that you know this. Next, we're going to talk about scatter plots. Now, scatter plots are very, very vital for machine learning. They're beautiful to look at. Just take a look at your screen right now, right? It is amazing that you can have and work with visualizations like this. It is usually very popular whenever you're taking a look at two numerical data points that you want to compare, side by side, or usually this becomes a result. A scatter plot is the result of what happens, when you plot a regressor line, right? Again, we've discussed linear regression in the case of the machine learning module. So once you plot what happens in the regression process, the eventual result is usually plotted very well and understood very well if it's done using a scatter plot, guys. That's the important aspect of things here. You might understand saying, okay, so can you give an example where what you see on the screen works? In that case, think about the number of clothes that you might wear based on the temperature around you, right? If it's 40 degrees, 50 degrees, you would be shirtless, you would be wearing very thin clothes, clothes that absorb moisture, your sweat and whatnot. And maybe if you're sitting on a mountain or if you're hiking in the Himalayan ranges, temperatures can hit minus 15, minus 20 and all of that, right? So there you'll be packed and stuffed with thermal wear, fleece jackets, outer jackets, and then, just you'll be stuffed to make sure your body can maintain temperature, right? If you want to plot both of those, that in the summer, these are the number of clothes I wear. In the winter, these are the number of clothes I wear. At the end of the day, it's a beautiful usage of a scatter plot as well, guys. So for the first important thing here, you're supposed to remember is that it's important for machine learning. The second thing is that it's aesthetic, beautiful, and really functional at the same time, right? The next thing we're going to take a look at is the strip plot. So strip plots are very, very similar to the usage of scatter plots. So what happens in the case of scatter plot is that we're going to be using two numerical coordinate labels, right? Temperature in winter, temperature in summer, and all of that. In the case of a strip plot, one of the values will be categorical in nature, while the other one is numerical in nature, guys. So when you're thinking about an example, think about maybe the amount of sales that happen on a particular day, right? Sometimes on a day, your sales might be amazing. On the next day, the sales might have dropped a little, and each dot you see there may be an individual sale for a week, sale for a month, or whatever it is, right? So you can see total bill is what is given on the y-axis, day is given on the x-axis. So on this day, you just sold 10, 20, 30, 40. You sold a product maybe which are worth these amounts. Total bill was somewhere in the 40, total bill was 50. So each of these dots represent a single bill with the worth probably shown on the y-axis as well. Again, this is a very simple example. You can find numerous examples in the case of strip plot. It is used very popularly, and if you're a person who is looking towards data science, you definitely require knowledge on strip plot, guys. So I hope all the plots that we discussed theoretically until now, you guys are clear with them, because the next concept that we're going to look at is a little different from the graphs that we have taken a look at, right? So now all the graphs, let me just go back: strip plots, scatter plots, box plots, histograms, everything we've just looked at is a graph. The next one we're going to look at is sort of a graph as well. It's called correlation. Now, correlation is one of these beautiful things that will eventually, it's like a matrix, but it's a colorful visualization of a matrix that will give you the interdependency between two variables, right? Let me show you one important use cases. Here you can see pregnancies written, and again on the x-axis you have seen pregnancies written. So what is the relationship between pregnancies and pregnancies? It is literally equal, right? So it has to be the brightest color possible. It's the same case with all the other elements, hence the reason why you see these diagonal elements to be maximum correlation or white in color, because you cannot differentiate between two exactly same values and say they're different. In this case, it is not possible, right? And then if you're taking a look at the dependency of skin thickness and pregnancies, well, it does not relate a lot as is what we can obtain from our data, because at the end of the day, you can see that there is black here. Black means that there is 0.0% correlation, that this data does not relate to the other data and have an effect on the output as well, right? So this is a very simple thing. So we've already done multivariate analysis in the case by using diabetes prediction. Just think about the same thing here, and that kind of a correlation, it adds a lot of value. We explained it there as well, and I'm repeating it now to make sure that you guys are clear with all of these concepts, guys. So I hope you understood all the plots that we've used. I made sure to take examples to help you guys understand all of them. There was a simple demo visualization there as well, and all of these is eventually theoretical learning to get you prepped for the practical session that we're going to check out, right? So guys, let me quickly head into Google Colab, and as always, the Google Colab is the Python Jupyter notebook that we're going to be using throughout this course. So I'm going to go there. We're going to check out all of these plots individually and practically, and see what are all the nitty-gritty things, the fine print that we have to understand to eventually use them effectively, guys. So let's quickly go to Google Colab and check them out. Right, guys, so we are in Google Colab. We're going to be checking out all the different plots that we just spoke about, but the one important thing that all of you guys have to know about is the order that we use to work with any sort of code in Python, right? So the first step is the most important step. We are importing Seaborn and we are importing Matplotlib, right? So as soon as I go on to run it, Seaborn is imported, Matplotlib is imported, then we're going to take a look whenever we're plotting line plots, right? So we're going to take a look at the fMRI dataset. fMRI set is a part of Seaborn. It basically talks about the data whenever you go on to have an MRI scan. It's a very complex thing which cannot be understood by a lot of people. You have the subject, the ID given to the subject, at what time point was there, what event, in which part of the brain, the parietal region it was taken, what is the signal that was firing from a neuron, possibly in that particular region of your brain. So it's a very complex data set, but we can simplify it by taking a look at data visualization. Right now, these are the first 5 elements of what our data set looks like. We have labels such as subject. Subject is of course the person, time point of when it was measured, event is talking about either a stim, or again we have another one which you're going to check out. Then you have region, what region of the brain, and what is the signal that was obtained from that part of the brain when scanned as well, right? So let's quickly plot a line plot by making use of time point and signal column data. Now time point is one column data, signal is another column data. So on the x-axis, what I want is I want time point. On the y-axis, what I want is the signal, right? So signal value versus the time point. Now as soon as I go on to use sns.lineplot, where x is equal to time point, y is equal to signal, and data is coming from the fMRI data set, I'm just telling that, hey, on the x-axis put all the values of time plot, on the y-axis put all the values of signal, and eventually show me what the plot looks like. Now as soon as I run this, you can see that this is a beautiful visualization, right? On the left, you have signal. On the y-axis, 0 is there. You have -5. On the y-axis, you have the individual time points and all of these. So this adds, instead of looking at this and saying like, okay, so I cannot understand anything. If you take a look at this, there's a good chance you can figure out that, hey, the minimum value of the signal was maybe .-07 or something. And then your maximum value touched somewhere around 0.15. This was the time point at which this particular part of the brain was doing this thing. So eventually, medical experts can understand this definitely better than me as a Python expert, but that is the case, right? Helping people understand things better. Now it is in blue color. There's a nice this thing running out on it, so it looks great even as it is if I were to understand this. But is there any way we can add more value into this? Well, of course, you can add a color to it as well. You can use a different color to go on to map it. Now, sns.lineplot, x is equal to time point, y is equal to signal, data equal to fMRI. This is exactly the same that we actually use, but here we are adding another thing called as hue is equal to event. So we're adding a hue from another aspect of data to understand what it looks like, right? So you have Q and you have a stim here. You have the data coming in from the time points. Again, on the y-axis you have signal. So you are seeing a differentiation of data where you have a hue called event, and this event data is also being published here, right? So the event says stim. So you can see the changes that happen between that time point and that aspect of signal as soon as you take a look at the data set. And all we added was hue equal to event, right? Everything else is literally the same thing that we checked out previously. Now, after adding the hue, after understanding time point, signal, all of that, so maybe you want to add some styling, maybe you want to change what the lines look like and all of that, you definitely can do it. As soon as I go on to hit play, you will eventually see that, for example, the Q visualization that we're seeing, instead of just being a solid line, it's now dashed or dotted lines, as you can see, right? So if you want this kind of a differentiation to help you understand it better, or if you want to look at it in a different way, or if that is a requirement where a legend value is different, this is something that you are going to use, guys. Now, building upon this, there are even more parameters that you can try to go on to use. In this case, see, we are not being shown how many data points have gone on to make this graph, right? It just looks very smooth, and sometimes maybe 1 or 2 points you can get 1, 2, 3, 4, 5, 6. If you look at where the line changes a little, there's a good chance there's a point there. But why to struggle so much? Let us have our markers show us how the data moves, right? Now if you can take a look at this, Look at that. These are the points. From one point to the other is how the eventual graph comes into being, right? Now with Q, again, there's a different style. There's X and dashes. In the case of stem, we have just circles and solid lines. So this is something that you definitely should know about when we are using line plot, guys. To go on to use line plot, sns.line plot, where sns is basically what we imported from cbar, right? It's a pretty simple way to go on to understand line plots. Now the next thing is, let us check out bar plots. But then in bar plots, as you can see, I've been importing a data set here, a very nice Pokemon data set. So let me go on to actually import it, and okay, perfect. So I already have it imported, all the data sets that we're going to be using further on to showcase the various visualization. If you're wondering about why I didn't import fMRI is a data set which is already part of Seaborn, so I didn't have to explicitly import it. But in this case, we are working on the Pokemon data set. Pokemon, I think, was an amazing TV show when we were all kids. I definitely remember coming back from school and running from school, in fact, sometimes, to make sure I get home in time to actually watch it and all of that. It was a beautiful part of our childhood. So let's take a look and use that data set to see if we can produce beautiful visualizations by making use of what? Bar plots, right? So the first step is, as always, you have to import whatever is the libraries that you're going to use. In this case, Matplotlib and Seaborn were already imported. Here I'm going to be using pandas. Why do I need pandas? Well, pandas is basically used to read the data set, right? So in this case, pandas has a function read_csv, which will help in bringing together and importing the data set. That is done. The next step we're going to be taking a look at is to print the first 5 rows of what our data looks like, right? Now, perfect. Look at this. Abilities of the Pokemon. There's an ability called as Blaze. There's an ability called Solar Power, Overgrow, Chlorophyll, of of these. Of course, if you know what Pokemon we're talking about, head to the comment section and let me know. There are multiple types of attacks: Dragon's Attack, Electric Attacks, and Fairy Pokemon. You have Dark Pokemon, you have Bug Pokemon, and all of that, right? So against Fire Pokemon, Flying Pokemon, Water Pokemon, what is the value of strength that each of these different? So every single row worth of data you see is a Pokemon. Again, against Poison Pokemon, Psychic Pokemon, Steel, Water, Attack, all of that, right? So what is the happiness? How happy is your Pokemon? Now, if we watch the show, we do remember 1 or 2 Pokemon which is always unhappy. They're annoyed no matter what their owners or their trainers do, right? So that's an important thing you have to know. So there's a lot of things. What is the classification? Is it a Lizard Pokemon, Flame Pokemon, Seed? How many has it been captured? How good is its defense? How much of experience does it need to eventually evolve or go into another form of evolution, right? Evolution was something that we checked out. You have Bulbasaur, Ivysaur, Venusaur, you have Charmander, Charmeleon, all these different Pokemon, right? Again, these are just little. I've just printed out the first 5, but we have an entirely huge data set that we're talking about. What is the index in the Pokédex? Pokédex is this identification device that they use to identify a Pokemon, and all of that, right? Even what type of attacks they have, what is their weight, what is their generation that they're in, Charmander, Charmeleon, Bulbasaur, all of those things, right? Then you have if it's a legendary Pokemon or not. If it's 0, it means the Pokemon is not legendary. If it's 1, it means that yes, it is a legendary Pokemon, right? Now, to understand and ask, this is an addition to the data analytics module. You can consider it for sure, because here, if there's a question that says, okay, so what is the speed of the legendary Pokemon that we have to find out when you compare it to non-legendary Pokemon? Again, SNS that bar plot where x-axis we're talking about if it's legendary or not, y-axis is the average speed data is picking up from our Pokemon data set, and when you hit plot.show. So here you can see 2 bar plots, right? First of all, x-axis is talking about if this Pokemon is legendary or non-legendary and the speed. Now, as soon as I look at this, I can find out, okay, if it's a non-legendary Pokemon, its speed is somewhere around 60 kilometers per hour maybe, but if it's a legendary Pokemon, it is way higher. The average of all of these, legendary Pokemons is way higher than what is available for the non-legendary Pokemon, right? It took me 2 seconds to find that out rather than look through 1,000 row data set. The next question we can ask is, okay, so instead of speed, can we check the weight? Do legendary Pokemons weigh heavier than non-legendary ones? The answer to that is an absolute yes, because as you can see, non-legendary Pokemon weigh comparatively very less, and legendary Pokemon are huge in their weight and size as well, right? So this is an amazing thing. Again, it took us 2 seconds. It's literally one line of code that is showing us and giving us so many insights, right? That is the beauty of data visualization. The next thing we can check out is, let's have the same thing. If X is legendary, Y is equal to speed that we previously discussed, data is coming from Pokemon. Here, like how we did with the line plots, we're going to add a hue here. Hue is based upon the generation when you're trying to compare. So you're trying to give a color to the various generation of Pokemon. So here that you can understand so many things. First of all, on the left, you have non-legendary Pokemons. In that, you can see if it's blue, if it's a first generation of Pokemon. If it's yellow, it's a second generation. Green, it's a third generation. So the evolution of Pokemon and their individual speed for their evolution is plotted as well. And the same goes for these legendary Pokemon as well. So there's level 1 legendary, level 2 legendary, level 3 legendary, right? So even when they evolve, you can find out the average speed at which they travel based upon their evolution. For some reason, evolutionary Pokemon, as they evolve more and more and more, their speed comes down a little. But yeah, see, again, you answered one more question even though you did not have to, or it just gave you an insight, a hidden insight, right? So that's the beauty of doing that. Now, we've been checking out all of these different colors, all of these different things. Can we use custom colors will be a different question that you're going to have. The answer is an absolute yes. Now, if I go on to plot the same speed and legendary graph, is legendary versus speed, this graph, but if I add a color element there and say, hey, a palette, it's called a palette here in the case of Seaborn. If I call it as VLAG or VLAG as it's called, is basically changing the colors into a more pink and a light blue, subtle colors that you're seeing on your screen right now. So again, this is aesthetic purposes, or maybe you're a person who wants to see everything in red. If that is the case, put color equal to red, and at the end of the day, instead of having a palette with different colors, it's just going to put everything on red and show it to you if this is what you require as well. This again shows what all is the things that you can do in the case of bar plots, guys. So I hope you understood bar plots. It's a very simple thing, and since with the case of Pokemon dataset, I hope it became more and more understandable by you guys and more fun. Right. The next data set that we're going to check out, and of course the next type of plot that we're going to check out, is this scatter plot. In the case of scatter plots, a very amazing data set to use to train all of you guys is the iris data set. The iris data set talks about the varieties of petals and the sepal length of a petal, three different types of flowers, and gives you a lot of data about all of that, right? So let me actually print the first 5 rows of it and show you. See, if it's a flower, you have setosa, and in fact, let's print the first maybe 20 rows to see what it gives us, right? As soon as you run this, you can see, okay, it's all setosa, for example, right now, but there are 3 types of species of flowers that we're going to be discussing here. So the 3 types of species that we're going to be discussing are setosa, virginica, and versicolor as well. Each of these types of flowers has its own width in terms of petal, the length, the width of the sepal, the length of the sepal, and how it differentiates from the petal itself, right? So a lot of details can be obtained from all of that. So guys, as soon as I go on to hit click, we're trying to map the sepal length and the petal length based on the data, right? As you can see, again, all the parameters are literally the same. X talks about mapping values on the x-axis, Y talks about mapping values on the y-axis. Data is from the IE's data sets. As soon as you use a plot to go on to do this, it is just telling you that the sepal length is this for this particular petal length. This can be actually divided into 3 different groups based on the 3 different types of flowers that the data set has. But having the capability to point out each and every single flower and say, hey, this is what its sepal length is and petal length is something amazing, right? Now, instead of me running through all of these manually, trying to break my head with the data, I look at this and I know easily what the sepal length looks like and the petal length is like, right? Perfect. But now, as you can see, everything is just the same color. It gets confusing to know what these 3 types of flowers are, right? So let's actually map it based on species and give it a different color. As I told you, there are 3 different species. You have setosa, you have versicolor, and you have virginica. Now, as you can see, all the blue colors has a sepal length which is not very big. It is from somewhere around 6 centimeters or whatever it is. Petal length is again very, very small. So the petals are tiny as very very tiny, and then your versicolor where, okay, the petal length is also really good, the sepal length is amazing, and then you have the biggest of the flowers in our discussion, which is virginica. Virginica are huge in terms of its sepal length and huge in terms of its petal length as well, right? So all we did is we added hue on. What did we add the hue on? What column did we add the hue on? Basically species, right? As soon as you add the hue, it is going to give you a legend, and of course it's going to color all the individual data points so that you understand it better. Amazing. The next thing we're going to add is, let's say if you want to differentiate between each of these flowers, if you want to add a hue based on the petal length, right? Now, if you add a hue based on the petal length, it will help you differentiate and understand it better. All these light colored ones have a very small petal length as and when it grows and grows and grows. When the color becomes darker, it means at the end of the day that, your petal length is changing. And as soon as I look at it, if I look at all the light colored things, I can know, okay, so the petal length here is very low. And as soon as I look at the dark ones, I'm like, okay, the petal length is amazing. So if that is an effect that you want to achieve, it is literally one word. You have to add hue and you are done. Previously, we added hue based on the species. So we got 3 different species, so 3 different colors. If you add the hue on a petal length, it is not 3 different petal lengths that we're discussing. It is a continuous variable, right? So here it just changes it based on the saturation in the color to make us understand it better, guys. So this was, scatter plot. I hope you guys understand it. Until now, we checked out line plot, bar plot, and scatter plot, right? The next thing we're going to check out are histogram, or as they called as disk plots. So in this case, we're going to be considering a data set. It's called as the diamonds data set. Now, if you're wondering about what diamonds data set is, let me print the data set for you to show you what it means. Now, whenever you take a look at a diamond, right, diamond is usually cut and polished. It has a carat value given to it. It has a clarity index. It has a color given to it. It has the size, shape, the price, the depth of color that you can see, or how well things are magnified on the inside, how good is the cut, because eventually the diamond's biggest thing is its cut. If it's cut amazingly well, it will reflect light way better and all of that, right? So as you can see, each diamond, each row of value you see here is an individual diamond. It has a carat rating. How is the cut? Is it just ideal? Okay, is it premium? It is good. What is the color that it's giving? What is the clarity it has? Depth, the price, the XYZ axis values to showcase its size and all of that, right? So this is the diamonds data set we have. Now, let us just take one column here. Let us take the price column here and plot an histogram based on it. Again, the syntax is very similar. SNS.dispLot diamonds of price. If I print diamonds of price, the plot that you're going to see here is something like this, right? So you have a function here that is showing your value as well, and you're actually getting the density too. So this is basically giving you density. As you can see on the left side, you have density, where how dense is that material compared to the price, and you're getting a functional value to go towards that as well. But let's say we do not want the frequency, or let's say we only want to print the frequency rather than showcasing our density, right? So in that particular case, if I just put histogram equal to false, so this is a histogram and a bar plot that you can see on the previous screen, right? If I just want the frequency curve, guess what? I just have to say histogram equal to false. If histogram equal to true, it is printing both the histogram and the frequency curve for us. So in this particular case, we just want the frequency curve and not the histogram, so we put hist equal to false, and the effect is achieved, right? It looks beautiful. The price, density, you just have one nice curve that is showcasing you what the frequency curve looks like. Now it looks very nice. Why not add some color into it, right? So we add another variable here. We add another parameter called as color, and maybe let's color it in green right now instead of having a blue colored line. If we just put here again, instead of color equal to green, along with that, if you put hist equal to false, you'll just get the frequency curve. But just to show you that it creates 2 different curves for the frequency chart and the bar plot and the histogram itself, I just showed you that. Maybe you don't want green, you want red. Perfect. You can have red as well. So there is a lot of support for colors. You can make it really, really beautiful to look at if that is what you want to as well, guys. So the next thing, we printed both histogram and frequency curve. We just printed the frequency curve. What if we only want the histogram and not the frequency curve, right? So in that case, you just have to put KDE equal to false. If you put the parameter KDE equal to false, here you will only have the histogram printed, but no, frequency curve that gets printed for you. So that is one important thing that you have to understand. And the next thing, right? In fact, even before you go to the next thing, let me show you what bins mean. Now, as you can see, this is one data. You have 2, 3, 4, 5, 6, 7. So every single trough that you see on the top, it is actually a line that goes, right? It goes like this into the x-axis. Now, in that particular case, these are individual elements that are called as bins. Now, maybe this is just printing us 100 different bins of data, which is eventually getting confusing. So I maybe only want 5 bins of data, right? So if I just put bins equal to 5, as you can see here, see how well this looks now. So instead of it breaking the data into so many things, 0 to 500, 500 to 1000, 1000 to 2000 and all that, here it is just taking, hey, 0 to 3000 is one bin. Let us just group all the data and print it, right? So you have 1, 2, 3, 4, 5. Just 5 bins, right? If you want 10 bins, of course you can do that as well. If I just change bins equal to 10 and if I hit play here, well, now you have 10 bins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, right? So this will give you a better clarity if you want to zoom in and zoom out to understand your data from a bird's eye view is something that's very important that you should know about, right? The next thing we're going to check out is how you can plot it on a vertical axis. Now, we have always been plotting a histogram on the horizontal axis, right? We have been starting from the bottom and going top, top, top. What if we want to start it from the side and go on to do it sideways, right? If you have to do it from the sideways, it is possible. There is another parameter that you're supposed to use. All the code that we have checked out until now is very, very similar. You just have to add another parameter called as vertical. Put vertical equal to true and it will give you a bar, it will give you a histogram which is again mapped on a different scale. As you can see now, it's instead of horizontal, everything is vertical, right? So vertical equal to true means that, hey, give me my histogram and put it out in the vertical way where I would want to see it like this for some reason, right? If you want to do it, you have the option to do it as well, guys. So this is a dist plot. This is a histogram. You saw how we can go on to print just an histogram, just a frequency curve, both of them at the same time, and a lot more things as well, right? The next thing we're going to check out is a box plot. Now, box plots are really, really fun to work with. For this, we're going to be taking a look at the customer churn data set. So what is the customer churn data set? Let's print it out and see for ourselves. Right. Now, customer churn dataset talks about if you are a person who is willing to buy or use a mobile service or a phone service based upon a lot of factors that talk about the company itself, right? For example, you have a customer, this customer is a female, he or she is not a senior citizen, they are a partner, are they dependents? No, they want one phone connection, they do not have services right now, they do not have phones right now, you're giving them internet, you're not giving them online security, are you giving them online backup, device protection, technical support, are you giving TV over the phone line, are you giving movies over the phone line, what is the contract like, is it 1 month that you have to pay every single month to month, or you just pay once for 1 year and this person has phone and internet and all of that, do you have to print a bill all the time, or you can you go paperless to save the environment, what is the payment method, do you have to send an mail with the check in it, or can you just pay it online and be done with it, all of that, what are the monthly charges, total charges, and if the person eventually bought the data set or not, right? So all of these you can try to predict if a person bought or not by again performing multivariate analysis here. So let us actually go on to use boxplot to plot churn and tenure to see if a person bought something based on the tenure, right? Now, what I mean by this, as you can see, is that the maximum number of people who bought the product, yes, right? So they wanted a smaller tenure. Now, if you go to 3 people and ask them, hey, you have to pay one amount which will cover the entire year, they might not have the budget or the finances to go on to do so. That is literally what is being showed here as well. As you can see, the tenure, if it is a smaller tenure, then people are likely to pick it up. If it's a larger tenure, it means that people might not be comfortable because they might not trust you. You might be new into the area. You might be a person who's giving the phone or internet services which no one has used before, so they don't know the reviews and all of that. So these people decline just because the tenure is long as well. So the person who's looking at it on the back end can understand, okay, so our tenure is long, this is the reason people don't want it, maybe let us reduce the tenure and have them on board, right? I answered a very important question there. The next thing is, maybe let us check out based on the internet services and the monthly charges that they're quoting, right? So if it's a regular DSL internet that they're using, the internet charges monthly charges are maybe the average, the median charges are somewhere around $60, minimum is $25, maximum is somewhere around $98, Q1 is somewhere around $45, Q3 is somewhere around $65, right? You remember the box plot that I showed you? This is exactly what we're discussing. Now, to analyze it, maybe for the people who used fiber optic connection, they are paying a lot more in monthly charges because they're maybe getting a better speed, they're getting more download and upload, FUP, the fair usage policy and whatnot and all of that, right? But for the people who do not want to opt in for an internet, well, they are literally paying nothing, maybe just a little bit of charges just for the phone line, but nothing for the internet, right? So you can see from this saying that, okay, there are people who definitely are using both fiber and DSL and people who are not using as well. The people who using the fiber optic are paying a lot more. That's an amazing thing which we just found out by taking a look at that, right? The next thing that we're going to take a look at is how you can plot based on contract. So all we are trying to change is the x-axis, y-axis values here, guys. Now there are people who prefer month to month contract here. Then there's another group of people who love a longer tenure, right? A 1 year contract is going to be a longer tenure, a lot of days. And then you have another tenure which says, okay, you have to pay for 2 years and you'll be happy. People are there. That is the point to show this particular graph. Month to month, there is a good amount of people. The average tenure is somewhere around 10. For the average tenure of 1 year contract, somewhere around 45. The average tenure for 2 years of worth of contract is somewhere around 60, right? So people are wanting and are willing to use either one of these. To understand what is popular, you can see the median values usually change in those. Nothing is at the center all the time, right? Because that denotes the line. This important line in the middle denotes the median values, right? The next thing we can print is how we can change the line width, right? Now the width of this gray color line that you see, maybe it's too small for you, so let's brighten it up. If we just set a parameter called as line width equal to 5, 5 is basically taking it from 1, the default is 1. If you put it into 5, this is what it would look like. If you are a person who wants to look at it better and understand it in a higher depth of clarity, this is what you would look at, right? So previously it was like this, the line thickness was very thin, it was at 1. Now if I do this with line width equal to 5, it just becomes bigger to look at, right? The last thing that we're going to check out is how we can plot based on our customized ordering on the x-axis, right? Now, if you can see here, line width equal to 5, until here, everything is the same, the code that we just wrote. The next thing is order equal to 1 year, 2 year, month to month. Here is where I say, hey, I do not want you to randomly print me an order. On the left, I want 1 year contracts. On the middle, I want 2 year contracts. On the right, I want month to month contracts, and that is how I want you to pay, or that is how I want you to plot a graph, right? As you can see, it is showing that all the 1 year contracts and the tenures are here, all the 2 year contracts are here, all the month to month contracts are here. If you want to change them around, all you have to do is just change the order here, and eventually you are given with that different order, right? Customizing your order on the x-axis, guys. So this is something which you can do with box plots. Box plots are amazing. They're really fun to work with, and all of these things that we just checked out, let me zoom out, right? Line plot, bar plot, scatter plot, histogram, or what's called as the disk plot, or even it's the other one that we checked out is the box plot, right? So all of these add a lot of value to your learning, ladies and gentlemen. I hope you were clear with all of these. If you're not, wherever you are stuck, make sure that you give a second, and instead of just copying whatever I just showed you here, explore on your own. Use different colors, use different palettes, use your own data set to map different XY variables to see if you can answer a question. As soon as you plot it, usually you will have a question in mind, right? That's how I did it in 2 or 3 times. I looked at the graph and I'm like, okay, so if the evolution is decreasing, as the Pokemons evolve, the weight is maybe decreasing or their height is decreasing, whatever it is, right? So I answered a question even without asking it. That is the advantage with data visualization, guys. So make sure you spend a good amount of time with data visualization. Now let's quickly take a look at the agenda for the session. Now when you take a look at the course agenda for multivariate analysis, we are going to be starting out by taking an introduction to understanding what data analysis is in its basic terms, right? Because once you have an understanding of what analysis is, then you'll be very curious to find out what are some of the various types of data analysis that we have out there. Now in these types, we are going to be dividing it down to the most simplest level. We're going to be assessing, we're going to be analyzing a lot of different things with respect to the various types of it, And as soon as we finish the types of data analysis, the right next thing that we're going to do is we're going to be jumping into the heart of the topic, wherein we will start out by understanding what multivariate analysis actually is, right? Now, once you have a picture of what it is, once you have slight clarity knowing, oh, okay, so this is what multivariate analysis is, you will be very curious to understand, fine, I know what it is now, but why do we use it? What is the primary objective of using multivariate analysis, right? So we're going to take a look at all of that. And once you understand what it is, where it is used and all of that, you'll be very curious to say, hey, okay, now what are some of the various techniques that I can go on to use now that I know the objective and what multivariate analysis is, right? So of course, we're going to have to take a look at the techniques as well. And once you understand the techniques and everything there is to know about, having a good introduction to multivariate analysis, you will be a person who will say, okay, so what are some of these advantages of multivariate analysis that gives it an edge over the other types of analysis, right? We're going to have to take a look at that, and of course we will. And lastly, as you can see, practical implementation in Python. As always, guys, anything with respect to data analysis, anything with respect to performing any sort of analysis, right? It will always help you if you always take a practical example to go along with your theoretical learning, and to make sure that at the end of the day you're applying whatever it is that you guys are studying and reading and understanding, right? That way it'll help you retain it better, and with the help of a demo you will understand exactly what it is to actually go on to perform multivariate analysis, right? So I hope all of you all are excited as me for this course. Let's get started with the first item on the agenda, which is introduction to data analysis. Now, ladies and gentlemen, data analysis is something which is fantastic because you might not know it's called data analysis, but I can guarantee you one thing: you have used it in your life a lot of different times for things which you might have never thought you would have used data analysis for. Let me give you a good example here. Now, think about a situation where there's a new TV show that is coming, or let's just say season 5 or season 6 of some TV show is becoming super popular. They dropped a trailer or a teaser or something. The entire world, as you know it, now that everyone's connected via social media, everyone will be talking about it. People will be going bonkers about it, right? When you think about it. So, what do you do when you see a new TV show which says, people are saying, oh, this is the best TV show I've ever watched. There is nothing that comes close to this. When people are raving about it, and when people are talking highly of it, what do? Because here is what I do, right? Once I figure out something is extremely popular and it is like, growing at a lightning pace, I am sure there is something in that show that is making people want to go and check it out, right? So I'm curious now. What I believe is, hey, okay, so if a lot of people are talking about it, there is something that the show is doing right. So let me find out if whatever the show is doing, if it is in my liking or not. Now, let's be honest, when it comes to movies and TV shows, we have our own choices, right? Now, for example, me, I love absolutely watching stand-up comedies, or if it's any new TV show or something, I usually prefer comedy or anything on the lines of that, right? Now, you might be a person who says, hey, I am into thriller and sci-fi TV shows and all of that. So what do? You quickly go to Google, you read more about it, right? You are trying to understand what it is at its core level. You go on to do research, you go on to do you want to read some reviews on IMDb, Rotten Tomatoes, all of these review places to see what people are telling about it. You'll watch the trailer yourself, you'll talk to a couple of friends. Now, what is this entire process that you're doing? You're trying to explore more into the topic, right? Now, look at your screen. It says, what is EDA? EDA stands for Exploratory Data Analysis. And ladies and gentlemen, to a good amount of extent, you guys were doing exploratory data analysis there because you knew what the problem was. The problem was you don't have enough information about the TV show. Now, you know how to solve it is actually by watching the TV show. But before committing to watching the TV show, you realize saying, let me do a little more research. Let me do a bit of analysis to see if this TV show is for me or not, and eventually you did everything that you would do, and then probably you either watched it or you didn't watch it, right? So taking a look at understanding this in the data analysis perspective that we're taking a look at, right? It's basically you having a problem, you have certain data, and you know that the data can be used to solve the problem. But as it is, if you just look at the data, it will not really give you any sort of insights, it will not give you patterns just by looking at it, right? You have to perform some investigations on it, you have to work on it deeper. Now, if I give you a single brick, a couple of bags of sand and a bag of cement and tell you, hey, build a house, right? If I just say build a house, do you think the house is going to be built? Not really. You're going to need people, you're going to need some process further to actually use all the raw materials to build. This data analysis is that raw material where you're actually investigating, right? That is very important for you all to understand. Now, there are so many things that is hidden in data that you will not realize as soon as you look at it with the naked eye. You can look at data with your eye and say, okay, well, there's not really anything that I can tell. There's a lot of rows, lot of columns, and we have certain data, and you can probably guess what might be happening. Guess, right? Now, I can guess that it will rain tomorrow here in Bengaluru, but how sure am I? I'm just guessing. I'm just saying it. It doesn't mean it has to happen. But that is where data analysis is very different. Here, when you make outcomes, when you predict something based on your data, when you're analyzing data and you say, here is the result of my analysis, basically what you're saying is, hey, I know that this might happen tomorrow. Here is the data to prove that it will happen tomorrow, right? Now, there you're not guessing anymore. You have data ready at your hand to back everything that you have to say, right? Now, if I say, hey, tomorrow it's going to rain because this is the precipitation factor, these are the clouds, that's how it's moving around India, you can expect a ton of clouds to be on Bangalore tomorrow, and there's a very good chance it might rain. Now, when I say it this way, you'll be like, oh, okay, it might rain, correct? Rather than just me saying tomorrow it'll rain. Now think about it. Now this exact small example that I gave you, this kind of an approach to understanding data is what is making it a key part of millions and billions and trillions of dollars worth of businesses today, right? Everyone around you, I bet everyone, right from the grocery stores near you all the way to someone in a very big company, maybe like Google, Facebook or something, these guys are using data analysis on a day-to-day basis. Of course, not everyone is sitting and working with algorithms, creating models and all of that, but they are in their own way performing some sort of analysis, right? Now, you closely observed what I just said, some sort of analysis. So what are the various types of analysis that one can go on to perform when we're discussing about data analysis, right? Now, ladies and gentlemen, you have to understand that there are three very important types of data analysis out there. It is not just multivariate analysis. We have univariate analysis, we have bivariate analysis, and we have multivariate analysis as well. Now, with respect to univariate analysis, it is very simple. What does uni stand for? All right, uni stands for one, uni stands for single. So whenever you are assessing and analyzing a single variable which will have an impact on the outcome, that is when we use univariate analysis. Now, when you have to analyze two variables which will have an effect, which will have a say on the outcome, that is when you use bivariate analysis. One variable done, two variable done. What if there is a case where we have more than two variables that we will have to analyze and assess? Again, you figured it out by now, right? It's multivariate analysis, which is basically used whenever you have to work with two or more variables. Now, ladies and gentlemen, do pause for a second here and try to understand and see if you can find any example cases of where you might have used univariate analysis, bivariate analysis, and multivariate analysis, right? If you're just analyzing one thing to see if it is right or wrong, that's univariate. Now, if you have two objects or something that you'll have to assess to see towards a common outcome, that is bivariate analysis. Now, multivariate analysis, again, there's a lot of factors that are involved, right? In fact, let us discuss these examples. Univariate analysis. When someone says, hey, analyze the change in the height of a particular person, in majority of the cases, how do you think it goes, right? So when they're young, the height is pretty much very less, and as they go in age, the age of 18, 20, 25, 26, they reach certain age and they tend to plateau at that age for a really long time. So it's a linear growth, right? It's not like one person grew 10 feet in a day. That really doesn't happen. So it's only one variable that you have to assess to give someone the height, right? You just have to assess, measure them and tell them, hey, this is one of the variables. This is one of the important things that will help you get to the outcome. Simple. Now, if I say, hey, analyze the change in someone's age, right? Age is still a single factor, right? You don't have to consider anything else apart from if you know the person's age. That is all is, let's just say, required for the analysis result. Univariate analysis says that if you only want to assess and analyze age, or not just age, this is just an example, this is what will lead to having one variable deriving and helping you get towards your outcome.
This is univariate analysis. Now take a look at bivariate analysis, right? Bivariate analysis is fantastic because here you will be taking a look at understanding two parameters at a time. Let me tell you. So think about sport preferences in our country, right? So not just in our country, it's just a hypothetical example out here. Whenever you're thinking about sport preferences, it is very common that, guys would love to play, cricket, guys would love to play football on the national and the international leagues, and women see themselves, mostly in archery. When you take a look at all these track and field events, which are again extremely difficult in my opinion, right? So if you say, hey, what are the sport preferences for male population and female population, look at this. You have two things that you'll have to assess and you have to assess your outcome based on, right? So male population, they will have their own choices, they will have their own sport that they like. Now if someone asks you a question saying, hey, at that point of time in 2005, what were the details of the male population, what games were they playing? Can't you answer that? Yes, you can. If the same question was asked in the case of female population, again, you would have analyzed a lot of different sports to get to the conclusion to say, hey, females in the year 2006 were playing these many games. Simple, right? So you can do it. Another example for bivariate analysis is the GRE score based on your ages. Now, when someone tells you, hey, I want you to take all the GRE scores of all the students who have written the exam, divided based on their age. Now you have two things that you'll have to filter something based on. First of all, you have to pick up all the GRE scores. Next, you have to pick up all the age of those particular candidates who have written that examination, and eventually then you can perform some analysis. There are two inputs, there are two variables you're assessing here, the score and the age at the same time, right? So this is bivariate analysis. When you take a look at multivariate analysis, you have got the game by now, right? So you will have to have more than two variables to actually check if a person, to check if an outcome is being achieved there or not. In the example that you can see here, it says diabetes prediction using insulin, age, BMI, etc. Right? In fact, we are going to take a look at a practical demonstration on the same particular topic. It's an absolutely fantastic demo because here, just think about the real life diabetes situation, right? There is never only one reason that will lead to diabetes, right? There's many factors. There's age, there's genetics, there's insulin, there's your diet, which matters a lot, there's your exercise habits, your blood pressure. There's a million things. There are so many variables, and if those variables fall into place, there's a very good chance that you might have diabetes, right? So this is again a common problem in today's world, and we are going to be using the power of machine learning to actually assess and analyze and perform multivariate analysis on it, because at the end of the day, we will know that, hey, diabetes does not just depend on one factor, it depends on multiple factors. So let's have each of those factors, let's perform some analysis on them, right? So guys, these are the various types of data analysis that we have out there. Now, coming to the heart of the topic, what is multivariate analysis, right? We took a look at examples. We understand that we're going to have more than two variables to work on it, right? Again, I can give you more examples on multivariate analysis because, as I told you, multivariate analysis, unless you search for it in your real world, you would not know you've used it. Think about it, right? Multivariate talks about always making use of multiple variables at a time. The same weather prediction example I spoke to you at the start. If I'm just telling you tomorrow it's going to rain, it's an absolute guess, right? It can be the sunniest day in the country tomorrow. But what if I tell you, hey, tomorrow it's going to rain because I assessed these many parameters. For example, the rain might depend on humidity, it might depend on pollution, it might depend on precipitation, it might depend on a ton of different other factors, right? All these numerical factors or categorical factors that will lead to that outcome of it raining tomorrow. Now, when that is the case, you have to be, you have to understand for a fact that it's not just one thing that lead to it. There's multiple things, and weather prediction is actually a very good example for all of you all to actually understand multivariate analysis, right? Now, you might be a person who might be saying at this moment of time, okay, I know what multivariate analysis is, but where is it popularly used? Well, we're going to be discussing a section just for that, but let me quickly give you some key pointers out here, right? Now, whenever you go to an analyst and say, hey, what are the sales figure of my company? Now, you might be a person who might have just opened a brand new chocolate company. You're selling chocolates, right? You will know that during this time, September, October, November, December, this is when people usually tend tend to sell a lot of chocolates, right? Because again, it's Christmas time, it's New Year time, there's Halloween, there's always something coming around these particular days. So you might be a person saying, hey, I want to use the last 6 month data that I have to try to see if I can predict what my sales will be during Christmas. Or even better, I'm going to give you the data from last year's Christmas sales, and can you guess how many customers that I can expect this year, so that I can order so many chocolates for the customers, right? So when you think about it, you can ask any sort of questions where probably 20 years back you could never answer those, right? And now you can not only just guess it out or something like that, you can have data to prove everything that you're saying. Now, it is very easy to say, hey, get 10 chocolates. How do you know it's 10 chocolates, right? So you cannot just say this is the factor which might be affecting the sales of any particular company out there. There's multiple aspects, there's multiple variables. There are so many dependencies which will lead to a situation such as this, right? So it is very, very important. Multivariate analysis, you have to understand, ladies and gentlemen, is a very important part of this domain that we call as exploratory data analysis, or EDA. So the next time whenever speaks about EDA, understand that multivariate analysis has a very important role to play in that, right? Now, once you understand where it is popularly used, you will be very curious to take a look at knowing the objective of multivariate analysis. We saw what it is, we saw where it is used, we saw to a certain degree how it can be used and all of that as well. But what is the overall objective? Why are we doing multivariate analysis? Now, ladies and gentlemen, multivariate analysis is basically done because of the following objectives you see on your screen right now. The first point says data reduction. Now, whenever you're performing analysis, whenever you're using multiple variables to analyze something, you can actually come to a point where you can reduce your initial data, because you might have had it in better categories, or you might be simplifying a very, very complex data set into something really simple. And at the end of the day, you're doing that. Here's the advantage. You're doing that without having to sacrifice any valuable information. Now, if I tell you, hey, here is this large chunk of data, here's the same chunk of data, but in smaller size, you might be the first person to say, hey, did you remove any data to make it smaller? Well, with the case of this type of data reduction, you can reduce the size of the data without having to sacrifice something which will add meaning to the whatever problem it is that you're trying to solve. This is critical for you guys to understand, right? Take a look at the next point. It says data organization. Now, whenever you're trying to perform multivariate analysis, it never is the case that, hey, look, these two parameters are the only reasons why this might happen in that particular way. No, there might be many cases where you'll actually have to go on to sort your data or group your data based on certain characteristics for you yourself to get some visibility to say, hey, okay, now we can go on to, now that I've grouped all this data, I have a clarity of what variable has what effect on the data, and now I can sit and perform multivariate analysis, right? So an objective is to actually reduce the data to its simple form. Another objective is to actually organize the data, and here is a very, very important one: data interdependency. Think about it. If we're talking about multivariate analysis, you're basically trying to understand the various relationships that exists between all these variables that you have out there, right? Now, think about this particular situation: age and fitness. How does it affect diabetes, right? Now, as and when your age progresses, when you're 50 or when you're 55, you might not be able to run like an 18-year-old kid, like a 16-year-old kid, right? So your fitness might come down slightly while your age is going up. Now, there is a relationship in itself. As you progress in your age, there's a very good chance your performance in terms of exercises, in terms of fitness, in terms of working out might slightly come down, because again, in general, we say, hey, it's an age factor, but it's a direct comparison between age and your level of fitness. And when we say it in conversation, you don't realize that it's again the interdependency that we're talking about. But now that you understand this, the next time you look at situations like that, I'm sure you're going to be thinking about data interdependency, right? Fantastic. The last point says hypothesis construction. Now, ladies and gentlemen, hypothesis constructions are very, very important, because hypothesis is something that you say that, hey, this might be right now. You might say that Pluto is a planet. There was a time in the world where everyone agreed Pluto is a planet, and then I don't know, it all went to bonkers. People don't, there's one side of the community that says Pluto is still worthy to be a planet. There's another side of the community who says no, Pluto is too small, too far to be a planet, right? So having an hypothesis that says, hey, Pluto is a planet, it's not going to be a wild guess. It's going to be you actually having to say, hey, Pluto is a planet for so and so and so reasons, correct? So to give out those reasons, you must perform some analysis. And what do you think? What type of analysis do you think goes into this? Multivariate analysis, right? So again, whenever you're thinking about all of these things, it is very, very important to first of all analyze. When you say data analysis, it's not just taking a data, analyzing and giving something out. There is way more sophistication to it, as you can see on your screen. And this is very important for all of you all to understand. Alright, now that we understood the various objectives of multivariate analysis, I think it is high time we dive right into the heart of the topic to actually understand what are some of the various techniques that we have in today's world to help us with multivariate analysis, right? Now, ladies and gentlemen, there's many techniques of how one can go on to perform multivariate analysis, and as a data analyst, it is very helpful for you to know what each and every one of these techniques is. Now, a common question I get whenever I'm teaching these techniques is, do we have to know all of this to an extreme amount of detail? Not really, because whenever you're given a problem statement, you will be using various techniques out there, let's be honest, but it doesn't add any sort of value for you to be a thorough expert in 100 different techniques when you might be just using 3 or 4, right? Give it a thought. So whenever you require any sort of technique, know what it is, know where it is used, know this. It's very important for you to understand how to use the technique to solve the problem. That is where all the magic lies in, right? So let's quickly brush through, let's quickly summarize some of these really popular techniques that we have in today's world where multivariate analysis is popularly performed, right? The first one on your list is multiple regression analysis. Multiple regression analysis, or MRA as it's called, is again one of the most commonly used multivariate techniques out there. Why? Because it is very effective even from a non-technical perspective, and at the end of the day, when you're performing multiple regression, right, it just solves all of your problem, because it will help you assess the relationship that exists between one single dependent variable and multiple independent variables out there. There is one single dependent variable, there's multiple independent variables around it. So if there's any sort of relationship that exists, this analysis method will show that out in bold to you, right? So when you have this kind of an ability where you have one dependent variable, multiple independent variables, here you can determine a linear relationship very easily, and eventually, to let's just say we are trying to use this technique to predict tomorrow's weather, it's going to be very easy. What is the goal here? The weather. What are the parameters that will help for the weather? Precipitation, pollution, humidity, all of those factors, right? So you're building a linear relationship between that, and once you go on to actually do it, well, you can predict tomorrow's weather, right? Simple. That is multiple regression analysis. Now, coming to talk about discriminant analysis. Discriminant analysis is again another very popular multivariate analysis technique. But here, what we do, things are slightly different here, because what we're doing is we're trying to classify all of our observations, and we're just creating multiple tiny groups, subgroups, bunches, whatever you want to call it, right? So we just take all the observations and we split it out into different groups. Now we can have a function that will basically classify all these observations that we have, right? Now, once you have observations, you divide it into groups, you will know roughly, vaguely what each of the groups or how each of those groups will behave, and then writing a function on it to make sure that you can, you can sit and classify the observations for sure. You're no longer guessing. You have a structured way of actually performing that assessment. You can do it, right? So it'll give you this ability to understand what variables will have more impact on the function at hand. Now, again, think about the diabetes example that I've been talking about, right? How do you know which has the biggest factor? Does having really high blood pressure cause diabetes? Does having really bad blood sugar levels cause it? You cannot say you have a bad age or something. You can say maybe you have a bad body mass index, right? Personal fitness. Maybe if that isn't up to the mark, and if you are obese or very obese or something like that, how do you know which of these has the highest impact, right? Using discriminant analysis, you actually have the ability to say, hey, this particular feature, this particular point of analysis might have that much that much of an impact on your solution. And that is very, very important for you to analyze as an important technique we have today, right? And then coming to another multivariate analysis technique, which is super popular, which is basically called MANOVA. MANOVA, or multivariate analysis of variance, is again a super popular technique which is used to assess the relationship between, note this is used to assess the relationship between many categorical independent variables and multiple numerical dependent variables. Independent variables are categorical, dependent variables are numerical. Right now, when is this the case? Give it a thought, right? I actually want you guys to analyze when is the situation where you will have a categorical independent variable and a numerical dependent variable, right? To give you a hint, take a look at it. It says very popularly used to assess the market trends. We know how the market works, right? It's just charts up and down, but when you have to analyze how much something is varying with respect to another point, you're going to have to take a look at the variance. And once you have to perform analysis on the variance, and if you have to perform multivariate analysis of variance, it's still called as MANOVA, right? It's a very simple generalization of what the technique is, what the technique does. But this point where it says this is the relationship, it will help you assess this relationship between many categorical independent variables and metric based dependent variables. This is something that you guys should understand, right? Coming on to the next technique, which is factor analysis, right? Now, factor analysis is also another very, very popular technique. Now, you might be taking a look at the trend here. I'm saying that this technique is very, very popular because data analysis is such a huge domain out there. Each of these techniques have become popular because they are very good at solving certain problems for multiple domains out there, right? Now, factor analysis is very different from all the various other techniques that we have today, because see, in the other techniques that you will have, we are trying to find relationships between variables, right? Dependent, independent, categorical, numerical, all of that. But here what we're trying to do is we're trying to understand the structure that is hidden in the data, rather than saying, hey, I want a relationship. And when I say I want a relationship, basically I mean the data point, finding relationships between each other, right? Now that is very important for you to understand. And I bet you have heard about factor analysis, right? PCA, principal component analysis. I'm sure you might have read about it, heard about it or something. And in fact, what you should know at this moment of time is that PCA is a very, very good example of actually performing factor analysis. A point where you say, hey, I want to understand the structure of it. I want to understand why the data, why the variables behave the way it is, and how is it linking to each other. When you are hunting for that structure rather than just looking for the relationship between the variables, you know what to use now, right? Factor analysis. And then we have another type of multivariate analysis technique here. It's basically called as cluster analysis. Now, cluster, what does the name cluster remind you of, right? Because in this particular case, when we are performing cluster analysis, we take a very, very large data set and we actually break the large data set into smaller chunks, smaller groups of individual elements, right? When we are performing cluster analysis, that's what we do. We take large data, we cut it out into small pieces, and we analyze those small pieces, and we try to understand, is there any sort of similarity when we're trying to cluster this? Is there any other characteristics which will group it into clusters, right? I'll give you an example. Think about apples, right? The fruit apple, not the brand. Now, whenever you're thinking about the apple fruit, there are so many ways. There is a raw apple, there is a ripe apple, right? The raw apple is usually green in color, the ripe apple is usually red in color. Now, what if I say, hey, can you divide this? Can you cluster these apples based on if they've ripened or not? What will you look at? You look at the colors. Hey, this is green, unripe. This is red, ripe. You're going to do that, right? So it's a characteristic that you're trying to assess. Similarly, when you have so many different things, especially market segmentation analysis, where you will have a lot of these categories where, your data is huge. It's absolutely huge, but you can try to group it down, try to simplify it and understand, hey, these are similar points of data that I can club. These are some of the characteristics which are making the data points look similar. So let me club these as well, right? And then later you perform analysis on it. How simple is that? But you have to understand one thing, ladies and gentlemen, factor analysis and cluster analysis, as we are discussing right now, these are very, very popular, very powerful, and people have started to realize that it pulls way more weight than people initially thought. So these are extremely popular for today, right? The next thing that we're going to take a look at is some of the various advantages of multivariate analysis that we can have today. Now, to talk about the advantages of multivariate analysis, there's a small problem. Because there's a ton of advantages that you can talk about, right? There's huge number of advantages which I can go on and on and on. But to actually simplify all of my thoughts into 5, 6 very good points, that's what you see on your screen right now. The biggest advantage of multivariate analysis is for a fact that it will help you arrive at accurate data-driven conclusions and insights. There's two ways of coming to a conclusion. One, you can guess it. The second one, you can have a conclusion and you can say, I have data to prove that this is the conclusion. Which would you pick? If you were a client, if you were an individual, if you were an enterprise user, which would you pick? You would of course want data-driven insights, data-driven conclusion. It will help you arrive at that, right? Not just data-driven conclusion, but accurate, super accurate data-driven conclusions, right? Now, the next point where multivariate analysis actually helps is to find out if there's anything wrong with the data, to find out if there's any anomalies in the data, and also to understand if to understand what is the level of consistency that you have with respect to data out there. Right now, this is very, very important for all of y'all to understand, because people usually think that, hey, multivariate analysis, you have multiple variables, you analyze it, you give some conclusions, you're done. Not really. It'll help you in a lot more places. Think about the third point, feature engineering. Feature engineering is actually a concept where you will try to analyze what parameters have what sort of impact on your outcome. Very similar to multivariate analysis, don't you think? Or in fact, it's an initial step to multivariate analysis if you take a look at it from another perspective as well. So telling that, hey, these are the features which will help me. Age is a feature that will help in diabetes. Genetics is also a feature that will help in diabetes, right? So you have multiple features that you're going to say that this will have, an outcome. This will have an effect on the outcome. Right? That helps. Again, feature engineering is extremely critical for machine learning. So give it a thought of how advantageous this is, right? And then data cleaning. Data cleaning is very, very important, because at the end of the day, again, if you consider a machine learning application, if you just provide unclean data to a machine learning algorithm, it is not going to realize. It doesn't know what a car looks like. It doesn't know what a ball looks like. It has absolutely no idea, right? It understands only zeros and ones. And through structure, it builds and understands and has certain meaning. But if your data is unclean, let's just say you're trying to collect the patient data. Someone has asked, what is your blood group, right? So some person by mistake, instead of typing in their blood group, they've written their date of birth, or they've written their mobile number. Right? Think about it. It can happen. It will happen, right? We're humans after all. So when something like that happens, and when you know that, the data is incorrect, and as soon as you feed it to your machine learning algorithm, it doesn't know it's wrong. What it's going to do is it's going to use that to learn incorrectly, right? It's not its fault at the end of the day, but that will happen. So with respect to using multivariate analysis, where you can clean and pre-process your data better, helps a million folds for all the processes which come down the line after analysis, right? Superb. Take a look at the last point. The last point says handling underfitting and overfitting. Underfitting and overfitting are the absolute, it will almost feel like, hey, these are small problems, but these have the biggest impacts on the outcome of whatever it is being done, right? Underfitting is when your machine learning model cannot really go into the depth of analyzing and assessing what's going on with the data. So it really cannot dig deep enough to find out any structure, pattern, or anything. But overfitting is reverse. Overfitting, it has dug so much into your problem, it has dug so much into your data that instead of looking at useful data, it has started looking at noise. It has started picking up things which might be of no use to your outcome. And what does that do? That both in underfitting and overfitting, it ensures at the end of the day your overall performance is coming down. Your machine learning model is not going to be performing well. Why? Because it's doing all of these things, right? In one case, it has absolutely no idea what sort of data to pick up and work on, where in the other kind of case where it's working so hard at a granular level that it does not know, it is not able to differentiate between noise, and it is not able to differentiate, and it is not able to pick up anything useful in both the cases, right? So to avoid all of that, to help handle it, again, you have multivariate analysis. Okay guys, fantastic. We've come to a point wherein we can actually take a look at that fantastic diabetes demonstration that I just mentioned to you all. And let me quickly jump to Google Colab. Google Colab is nothing but a Jupyter notebook that is hosted on the Google Cloud platform. Now you guys can code this in any other choice of IDE that you want. Your PyCharm, you can use the regular Jupyter notebook. It's basically a simple Jupyter notebook, but it's on the Google Cloud, right? So let's quickly get into that. Alright guys, as you can see, I've opened up my Google Colab out here, and all we're trying to do is we're trying to perform the diabetes detection. We're trying to understand how we can get a machine learning model to figure out what are the various factors, what are the various points of analysis that will eventually lead to the result, right? Now ladies and gentlemen, the goal here, one thing you have to understand is that the goal here is not to show you how easy. Of course, one point you have to understand that to achieve this particular demonstration, it's very easy, but I understand that some of you all might not be might not be up to speed with respect to these libraries such as NumPy, Pandas, Matplotlib, Seaborn. So let me quickly give you a glance of what's happening with respect to each point of code, but you actually try to analyze and assess the MVA, the multivariate analysis aspect of it, right? Well, the first step of any analysis out there, we're gonna have to import all the libraries, right? NumPy is called as numerical Python. It's basically used to perform all these numerical related activities when we are working with Python. Pandas will give us two fantastic data types. It's called as the Pandas series and the Pandas data frames, which are again very important for us to work with. And then we have Matplotlib and Seaborn. Matplotlib and Seaborn are critical libraries when it comes to data visualization. If you have to plot anything with respect to using graphs, charts and all of that, which we are going to be using in this small demo, so you're going to require that. And then we have sklearn. Sklearn also stands for scikit-learn, which you might have heard. It's a very important library for machine learning. Right now, as soon as I hit this play button, it's very simple to actually work with Google Colab here. Now, as soon as I hit the play button, it's going to take a second, and as soon as it stops, basically it has executed this. Right now, all these libraries are ready for me to use. Now, the next step is for me to actually talk to you about the data set, right? To show you what the data looks like. But if I just hit play on it, it's going to give me an error now. It's going to say, hey, where is that file that you're asking me to open? Well, it's actually in my local computer here. Let me open up these files. Now I have to upload it to the Google Cloud so that it understands, right? Now this entire Python environment is on the Google Cloud. Now that I've uploaded it, I'm going to close it. I'm going to hit play again. And as soon as I hit play again, done. We have actually uploaded our data set. Our data set is ready. So let's quickly take a look at what the data set is all about. Now I've printed the first 10 patients worth of data. Now every row you see here is one patient's data. Okay, so we have multiple ones. We're going to see how much we have in a while. Now, what are these various factors that cause diabetes, right? One is your glucose level, the blood pressure levels, what is your skin thickness, what is your insulin level, what is your body mass index, what is your age, and eventually the last column will be the outcome column, right? Now, if the outcome is 0, it means this person does not have diabetes. If the outcome is 1, it means that person has been diagnosed with diabetes, right? So we already know. We know that, hey, this is the detail of the person, and if the person has diabetes or not, we know. But what we are going to do when we are supplying the data to our machine learning model is we're going to just remove the last column and say, hey, now you predict if there is any sort of use your multivariate analysis result to see if you can find out correctly if the person has diabetes or not, right? So that's about it. BMI, again, when you think about it, I think 25 is the normal value. Anything about 28 or 30 is something is where you are called as an obese person. Anything less than 25, if it is like around 20 or something, you're malnutrition or something along the lines of that, right? You guys know this. Now, the important part that you have to be asking me right now is, hey, okay, so you just printed out for the data for 10 people. How many people do we have in total to analyze all of this data? As you already know, to perform multivariate analysis, we require a large amount of data, correct? Yes, in this case, as you can see, for each of the patients, for each of the columns that we have, which is showing a parameter, which is showing a variable, we have 768 entries. What this tells me is that there are 768 patients worth of data that I'm looking at right now. Okay, so if there are 768 people who are, going on to giving me some data points out there, what are some of the things that I can tell as of now with respect to a statistical description? Well, the first the row here, it says count. Count is basically telling me how many entries there are with respect to that column. As you can see, it's 768 everywhere, so we don't have any empty columns or rows out here. And then it is giving me the mean of it. Mean is basically the average, right? Now, in the entire 768 people, you can see that the body mass index average is actually 32, which means that overall, there are, if you consider this, the data set in general, this is a hypothetical data set, the body mass index is slightly higher than what we would prefer, which is around 25, 26, 27, right? You can take a look at all that. You can take a look at the standard deviation. You can find the minimum values. You can find out what is the value at the 25th percentile, 50th quartile, 75th quartile, and eventually even the maximum value as well, right? So there are various things that you can figure out from this. Looking at it, as soon as you take a look at it, you'll be like, oh, okay, so this is what is happening with respect to all of these individual entries, right? This is taking your entire data set, and instead of walking you through each of those 768 entries, this is me giving you a statistical aspect of it. Say, hey, look at this. With respect to one command, right? Data.describe is all that we use. With respect to data.describe, done. We just used it and we realized that we can find out so many things about our data set, right? Now, the next thing is the part where we'll actually be performing some pre-processing with the data. Now, thankfully, in my case, I do not need to perform any sort of pre-processing here, because all of these values, wherever it says false, it means that there's only numerical values that are found. Is NA is basically telling, is it not a number? Is it anything apart from a number? So wherever it says false, it means it's a number, correct? Now, again, as I told you, right, when I ask someone, hey, what is your body mass index? Please input it into this column. They might have written O positive blood group, right? Of course, they don't do it on purpose, but it is done by mistake. And if it says true here in many of the point of cases, it means that there is a wrong entry there that you have to go and fix it up. Now, in my case, as I told you, this data set, this hypothetical data set is already cleared. I don't have to perform any sort of pre-processing on it. The next thing that I can jump directly is to understand this concept called correlation. Correlation is a beautiful concept, especially for multivariate analysis, because here it will tell you how much of dependency exists between two variables, right? First of all, take a look at the heat map on the right. If it is, of course, there's positive correlation, there's negative correlation, and all of that. To simplify it for your case, we're just going to be talking about positive correlation here. Now, whenever there is this chart that starts from 0.0 all the way to 1, you can see that the color lightens. When the color lightens in the legend, it's basically telling you that whatever, if it is at that color, that is the amount of positive dependency, the correlation that exists between these two variables, right? For example, pregnancies and age, right? Age is here, pregnancy is here. So this is the box that we're talking about. You can see that this is light in color compared to all the other boxes, right? So pregnancy and age has a good amount of correlation there, and wherein the you could figure it out just by looking at your data. Now you might be looking at the diagonal elements and saying, hey, those are white. Does it mean it's exactly equal? Yes, it is exactly equal. I'll tell you why it is white. Because if I have to compare the value of glucose, now this is white. What are we comparing it with? Let me scroll down. I'm comparing it with glucose itself. Glucose compared to glucose for any person, if it is like 300 versus 300, isn't it exactly the same thing? Yes. Similarly, for blood pressure, skin thickness, insulin, BMI, all of these different parameters, you have to take a look at it, wherein each and every one of those, when you compare it with the exact same thing, it's always going to be 100% equal, right? So all the diagonal elements will always be, be white in color, right? So you can analyze various points here. For example, take a look at insulin and skin thickness. Insulin has some sort of relationship with skin thickness because this is a lighter color compared to all the shades around it, right? So like this, you can actually sit for a couple of minutes, try to analyze and try to write down what are some of these correlations which will be very important for you to later not only understand these are the variables that have the outcome. With respect to correlation, you can say these are the variables that have so and so outcome, right? You can attach a numerical metric to it to say, hey, pregnancies are 80% related to age factors or something like that. You can always go on to perform all of that with respect to a simple correlation matrix. Now we know that we have 768 people. How many people do we have who have no diabetes, right? As soon as a couple of lines of code, 3 or 4 lines of very simple logic will tell me that there are 500 people who don't have diabetes. Another piece of code tells me that there are, of course, if there are 500 people who don't have diabetes, it is 268 people who have diabetes. Now you might be saying, hey, wait a minute, I didn't understand. How did you figure it out? Let me scroll up to the data set and you can see this last column 1 and 0, 1 and 0, right? So all I have to do is I have to filter everything here. If I just have to pick up everything that is 1 and count how many are there. I have to put everything which is 0 on the other side, count how many are there. That will give me the total number of people who have diabetes and who do not have diabetes, right? That's all I did. But if you still want a simpler explanation, as always, with the help of data visualization, you can take a look at it. If the outcome is 0, it means the person does not have diabetes. If the outcome is 1, it means the person has diabetes. Now you can see that it is a sharp mark at 500, means 500 people don't have diabetes, and here somewhere around 268 people, roughly around 268 to 70 people have diabetes, right? Now you can just look at this graph and within 2 seconds you can figure it out. If you're a person who says, oh, I don't really like to write all of this code just to find that out, 2 seconds, create a try to create a plot, and you will have all the details in front of you, right? The next couple of steps are pretty simple now. Multivariate analysis is where now is where machine learning takes over a bit. The next thing that we need to do is we need to break the data apart into 2 pieces. One is the training data set and the other one is the testing data set. Why is this done? Well, this is done to make sure that we have brand new data that our machine learning algorithm can test later on. It's just like your college examinations. You read using your textbooks, you close your textbooks, and eventually go write your examination from your memory. Why is that done? That's done to see how you have learned, what it is that you have exactly learned from those books. We want you to reproduce your learning, right? Similarly, if we divide stuff out into 2 pieces and if we hide one piece for a later verification stage, we can understand and we'll know that it has learned it better, right? Because if I give it the training data right now and later send the same training data again, it will give me 100% result. It will say, hey, everything is correct. That's not what we want, right? It's like having your textbook next to your examination. We don't want that. So basically what we're trying to do is when we are providing the data to our machine learning algorithm, that last column which said outcome, where it had the details of if a person has diabetes or not, we're going to drop it. We're going to remove it straight away, and we're going to break the data into 2 pieces. One chunk, one basket consists of 80% of data, while the other basket consists of 20% of data. Now, for all the people who are not used to machine learning, if you're a person who's thinking, oh, I'm going to require hundreds of lines to perform machine learning, not really. As soon as I click this particular code snippet here, these 2 lines that you see, L equal to logistic regression and model fitting, is a place where we actually provided it with respect to the training data. And as soon as this is done, the model has actually finished learning everything. The next thing is where I give it that test, where I tell it, hey, here is new data, tell me if you can predict this correctly. And with again 1 line of code, that is done. And after that, you have one more. All of these are basically statistical concepts. It's the measures of accuracy here. There are concepts such as true positives, false positive, true negative, false negative. Those will actually be used to assess and gauge the performance of your machine learning algorithm. But for simplicity's sake, let's have an accuracy score. It says the accuracy score is 74.67%. All that it is trying to tell us is this machine learning algorithm could figure out what are the various factors that's going to lead to analysis, that's going to lead to diabetes, and we made sure to take a look at it manually with respect to performing MVA over using correlation. Once we did that, we figured out how many people have diabetes, how many people don't have diabetes. We printed a small graph. We used logistic regression, and at the end we printed out an accuracy score to say, hey, by not only just performing multivariate analysis, I have also used the result of multivariate analysis to feed it into a machine learning algorithm and get the machine learning algorithm to predict if it can find out if the patient has diabetes or not. How fantastic is this, right? We started out by thinking, hey, this demo will only be talking about multivariate analysis. We also made sure to have a bigger view at the picture to tell you exactly not just how multivariate analysis works, but again, whenever you think about where it is used, this is where it is commonly used. It is attached with either machine learning or deep learning to drive insights based on those results, right? So it's very important for you to understand. And as I just told you, right, the goal here for you is actually to understand the structure, to understand how we try to attack this particular problem and solve it. And of course, there might be some of you who are watching this course right now who might be saying, hey, I don't know why you've written this exact line like this. Yes, you're going to require a bit of introduction to Python to understand how Python syntax is written, to actually go on to figure all of this out in detail. But that's not the goal here. The goal here was to show you multivariate analysis and to also give you an extended view about using machine learning there as well. Well guys, with this we have come to the end of the course. Thank you so much for watching. We started this one out by taking a look at understanding what data analysis basically is. Once we figured out what data analysis is, we took a look at the various types of data analysis we could perform. Once we understood the various types of analysis, again with very good examples, we homed in on multivariate analysis. We started understanding what is multivariate analysis, where it is used, what are some of its popular applications, what are its very good techniques that are used everywhere around us, what are the advantages of it, and we also made sure to take a look at practically implementing the concept to showcase to you guys that in a practical situation this is how you would be performing multivariate analysis. Now there's so many other use cases, there's so many, it has literally an almost infinite outcome wherein you can find a problem statement and perform multivariate analysis on it, right? Because usually that is the case, that is how it happens in the real world, and the real world has realized it, and that's the reason why we are seeing data analysis to be blowing up like we've never seen before, because people realize now that having data, performing analysis like this will not only help them clear out any something might have gone wrong in the past and you're trying to fix it, but it is also giving you an ability to forecast what's happening in the future, and not a lot of domains give you that, and that is the power of data analysis, right? Okay guys, superb. Thank you so much for watching. My name is Anirudh Rao. I hope you're clear with everything that I've covered in this particular course. As always, see you on the next one, right? Have a good day. Cheers, guys.
In this particular part, we are going to talk about anomaly or outlier detection. What is anomaly? What is actually mean by outlier detection? We will talk about everything. So let's see, and let's go to objectives, and let's see what are the things we are going to talk about in this particular part. So first, we will start with what is statistics. Right, so this anomaly detection or outlier detection is nothing but the basic part of statistics you need to know. Then we will talk about what is population. Then from there we will have a look at what is parameter and sample. These are nothing but basics of statistics. Then I know you all have idea about what is mean, median and mode. Again, for your recap, we will talk about that. Then we will see what is normal distribution. Then types of analysis and statistics we have. Then we will start with what is an outlier, what is interquartile range, in short which is known as IQR. Then we will see what are the interquartile range, like upper range or lower limits, what it is. We will talk about in depth for interquartile range. Then we will do a demo how to handle outlier in the data set. Right? So let's start with our what is statistics. So first question is what is statistics? So what do you think? What is statistics? Right? So statistics is a part of integrated applied mathematics which deals with data. Right? It helps to collect data and analyze them properly. Okay? So if we know maths, it's a integrated applied mathematics. Right? So basically, it's help us to understand our data in a more better way. It gives us the idea that, okay, maybe your data is coming from this. It's like, these are the insights you can actually have a look at. That's why we go for statistics. Right, in a very basic part, as a data scientist, you need to have an idea about what is stats, right? How can you understand your data using statistics concepts? So it helps to collect data and analyze them properly. From there, with the help of statistics, we can read the data and organize them in order to get the hidden information from them. The main reason behind it to use statistics, it gives us really some, we cannot even think of by looking at the data, but actually the data has those insights or the information. So they are nothing but our hidden information. So this is what statistics stands for, and that's why we try to use all the concepts from stats. In data science domain, statistics concepts are used to process the complex data to get the insights from them using mathematical computations, right? So it's basically, again, it helps you to process it's a complex data, and it give you a really good insights from them just by using stats. So let's start with like what are the terms we have in statistics. So this is the slides we talk about. You can see stats, what is stats, why do we need it, and why we say while it comes to data science or artificial intelligence, you need to know the basics of stats, right? I think you got all the idea about why do we need stats. So please let me know in the comment section if you feel like you are not yet convinced that why do we need stats, right? Then we will talk about what is population. The terms population in statistics is used to refer the total set of observation. Okay, let me tell you what actually I mean by total set of observation. So total set of observation is nothing but when you have a data set, right? Or you can think about the example of the whole population of the world. Yes, that's what population stands for. The whole population, the whole total number of human beings we have in the world, right? So, suppose again, we want to study a diabetes data set to understand the symptoms and the other factors in the whole data set is referred to as population, right? Now, if I just go and talk about what is parameter? So parameters are referred to as characteristics which describe the population, right? It's help us to describe our data set, right? So this is what stands for parameter. Parameters are like average or percentage which help you to describe the entire population. Suppose you have a diabetes data set and you want to understand what is the average age of being diabetic. I know, how can you do the average? So this average is going to represent your whole data set, right? So you can understand what is parameter. Mean and standard deviation are two common parameters of population, right? Now, example, I have given you already average age for being diabetic is the parameter for whole diabetic dataset population. Now we will jump into what is sample. So if you have a lot, we have the whole population in the world. Now if you just want to talk about West Bengal or if you just want to talk about India, right? Then the India will be your sample from the whole population, from whole world population. This is what sample stands for. Sample is basically a small part or the portion of the large population. Now, suppose from the whole diabetes dataset, you picked 100 rows of information to do the analysis. That 100 rows of information will be referred as sample, right? Now let's move further. We will talk about what is mean. The term mean is referred to as an average value of the whole population that we already know. Now if we talk about median, so median is the middle value of the data when your data is sorted in the manner. Yes, to get the median value, you have to make sure that your data is sorted. Now we will talk about mode. Mode stands for the most occurring element in the data set. So mean, median, mode is the very basic things, right? We start learning those things when we are kid. So still, if you have any doubt regarding what we have talked about, why do we need statistics, what is population, what is sample, then we talked about what is mean, median and mode. Now we will talk about what is normal distribution. The normal distribution is a probability function which describes you how the values of the variable are distributed. Now we will say why do we need it? This basically give you an idea about your data points. Who are your data points? Suppose you are talking about diabetes dataset. All the rows you have about the description or the information about the person, these are your data points. Now, this normal distribution is basically comes from probability function and it helps us to describe how our values of a variable are distributed properly to give us the idea what is the range of our data set, right? This is what normal distribution stands for. Now, properties of normal distribution, the mean, median, and mode all are equal, right? The curve is symmetric at the center. Then this is also referred as Gaussian or Gauss distribution, right? The parameters of normal distribution, mean, standard deviation, we have the parameters of normal distribution, that is mean, and the standard deviation, right? Now, we will talk about the types of analysis in statistics. Basically, we have two types of analysis. One is descriptive statistics, and second one is inferential statistics. What is descriptive statistics? It helps to describe the data in the mathematical or a graphical way. Now, when it comes to inferential statistics splits the data into samples and applies probability to arrive the conclusion. Right? This is what descriptive statistics and inferential statistics stands for. Right? I hope you understand what is actually mean by descriptive statistics and inferential statistics. So, as the name suggests, again as a recap, describe the data, you need to have descriptive statistics. Now, if you want to use, split your data to samples, I hope you understand what is sample and how can you apply probability to arrive the conclusion. We use inferential statistics, right? Now let's move further. We will talk about what is an outlier. Outlier in the data set are referred to as the usual values which can distort and violate statistical analysis. Now you will ask me, what is outlier? Maybe in the class there will be always an outlier. What is an outlier? Suppose we have students who are mediocre, or we have student who is really good, like the first boy or the first girl, right? So they are nothing but the outlier, right? So this is what outlier stands for. Now, outlier are basically experimental errors in the data set, or like in the case of data, it's an experimental error, but in the case of what example I'll get, it's not an error, right? Now, some outliers are good for dataset to detect anomaly, like detecting fraud transaction. Now, you will ask me, how can we detect a fraud transaction? Let me tell you. So, basically, detecting fraud transaction is like, suppose you have a dataset where everyone has done the credit card fraud analysis, or everyone has the idea, like description or the information about their credit card. Suddenly you see there is a sudden spike in the transaction when a person is used to buy something between 10,000 to 20,000. He's going to buy something in 10 lakhs. It's nothing but the outlier, and there is a possibility it's a fraud transaction. I cannot say it's not a fraud transaction. So it can be a genuine transaction, but yes, but there is a possibility. As the outlier is there, we would need to give a good look on that, what is happening. So this is how we actually use our outliers. Now it affects the mean and the standard deviation of the data, that's obvious, and the data and the most of the machine learning techniques does not perform good with outliers. If you see outliers is not needed, you can just cut it off, because it's going to affect your model and it's going to affect your data, mean, standard deviation, everything, right? Now we will talk about what is interquartile range. Interquartile range divide the dataset into quartiles to measure the variability and the spread of the dataset, right? So what is that? It's basically help you to divide your dataset with 4 quartiles to measure that how your data is spread, what is the variability, what is your data points, to give you the every possible way information about your data. Splits the data set into 4 equal parts, but in sorted manner, right? So Q1, Q2, Q3, Q4, right? We will have 4 parts. So Q1, Q2, Q3 are called first, second, and third quartile. Now, what is Q1? Q1 is the 25th percentile of the data set. What is Q2? 50th percentile of the dataset, and Q3 is 75th percentile of the dataset. This is what IQR stands for. Now, what is the formula for IQR? That's nothing but third quartile minus first quartile. Now, we will talk about what are upper and lower limits in interquartile range. Yes, you have to have an upper limit and lower limit. Now, let's have a look at what is upper limit and lower limit. Now, we've had upper limit and lower limits in the interquartile are basically the ranges where your data points are lying. Suppose it starts from 0 to 15. So upper limit is 15 and lower limit is 10. Lower limit is 0. right? So formula to find the lower limit is basically Q1 minus 1.5 into IQR. Now to formula to find the upper limit will be Q3 plus 1.5 into IQR. And what are the concepts we have learned about what is statistics, what is sample, what is population, what is mean median mode, what is IQR? We will do everything, right? And how can you find outlier as well, right? So let's start with the dataset demo, and do let me know if you have any doubt in the comment section. In this case, we are going to use a dataset from Kaggle, which is known as PIMA Indian Diabetes Dataset, right? So this is your dataset link. If you just click over here, you will redirect to the dataset, right? Let me do that. Okay, so again, it's a free dataset from Kaggle where you have the information about diabetes patient. Can you see? This is how you will redirect and you will directly download the dataset from here. It's from Kaggle, right? Can you see? This is what the dataset is. Right. Now we will talk about what is this dataset all about. What are the thing we have? The PIMA Indian Diabetes Database is from National Institute of Diabetes and Digestive and Kidney Disease. It consists of 9 variables. We will talk about that. Out of which outcome is the target variable. The objective of this data is to aid in pending if a person is likely to have diabetes or not. What are the different types of diabetes we have? The most common type of diabetes are type 1, type 2 and gestational diabetes, right? Now, what is type 1 diabetes? Type 1 diabetes, if you have type 1 diabetes, your body does not make insulin. So we all know about diabetes that it does stop making insulin. Your immune system attacks and destroy the cell in your pancreas that make insulin. Now, type 1 diabetes is usually diagnosed in children and young adults, although it can appear at any age. People with type 1 diabetes need to take insulin every day to stay alive. Right? Now it comes to type 2 diabetes. If you have a type 2 diabetes, your body does not make or use insulin well. You can develop type 2 diabetes at any age, even during childhood. However, this type of diabetes occurs most often in middle age or older people. Type 2 is the most common type of diabetes. Now, if we talk about gestational diabetes develops in some women when they are pregnant. Most of the time, this type of diabetes goes away after baby is born. However, you have gestational diabetes, you have a greater chance of developing type 2 diabetes later in life. Sometimes, diabetes diagnosed during pregnancy is actually type 2 diabetes. Other types of diabetes less commonly include like monogenic diabetes or which is an inherited from diabetes, and slightly fibrosis related diabetes. So these are the type of diabetes. Maybe you think why I'm talking about diabetes, just to give you a heads up if you do not know what is diabetes, right? So we have talked about different type of diabetes. Now we will see what is the data description we have in our data set. What are the 9 variable we have? We have pregnancy, the number of time the patient got pregnant. Then we have glucose, that plasma glucose concentration. Then we have the column called blood pressure. It's like, we all know that is BP, right? Then we have skin thickness, that tricep skin folds thickness, right? Then we have insulin, the 2-hour serum insulin. Now we have BMI, that is body in mass index, weight in per kg. Weight in kg per height in like to the power 2. This is how we calculate BMI. Now we talk about diabetes predictory function, which is nothing but again diabetes predictory function. Then we have age and outcome, that will be your class variable, 0 or 1, right? So these are the total column we have. Now you will say, what is this outcome stands for? This outcome is basically if your outcome is 0, this person is diabetic, not diabetic. If the person is diabetic, then the class variable will be 1. right? So this is what the different type of columns we have. Now if we go further and if we have a look at what are the library we need to import, then we have talked about pandas, numpy, matplotlib and seaborn. We are going to import this four library, right? We have written import pandas as pd, import numpy as np, and if you know why we use as, please do let me know in the comment section. I would love to hear from you, as we have talked about this particular as so many times. So what actually I mean by import pandas and then as pd, right? Please do let me know. Now like after you write this comment, then again start the video and let's see what you have written, it's right or wrong. And guys, if you like the video, do not forget to like it, do not forget to subscribe. Great learning, so you will get updated with the all new content we are going to come up with, right? And please do let me know in the comment section, do you like the video? If you like the video, what are the things you want to learn from us as well, right? So now we will do what? We will load the data set. How we do the loading the data set? We can write data equals to pd dot read underscore csv. What is csv file? Comma separated value, right? Yes, this is what csv stands for. And then we have written diabetes.csv, right? So you have your data, and if you just want to read them using pandas, you just need to use dot read underscore csv. So my data is a comma separated value, right? So csv stands for comma separated value. Now if you ask me how can I upload data in Google Colab, I have talked about so many times, but for your reference again, just click on this particular box. Here you will get an option for upload to session storage. It will redirect to your local system and you just need to upload the dataset from there. So this is how I have done. Now here pd.read.csv, you have to give the path. How can I get the path of the dataset? Now, if I just click over here, you get an option for copy path. Let me just copy the path. Now, just copy paste it here, right? This is how this copy path option works. And this is how you can read the dataset using pd.read.csv, and you can upload dataset in Google Colab. Right? I hope you do not have any doubt till so far what we have talked about. Give me a quick confirmation on that as well. Right? Now we will see the basic part of pandas, and then we will jump into all the all the techniques we have learned, and we will see how can we implement them using Python. Now we have written data.head. Why do we write data.head? I have talked about this again for so many time, while we were talking about PD, like pandas, right? Okay, I have asked you guys question that why do we use as PD? As PD is nothing but giving the alias to your library, right? So if I don't want to use pandas for all the time, I can easily call them as PD, right? It's a nickname to your library, you can see in a layman term. Now if we just write data.head, it will return you the first 5 rows of your data. Let me just execute that. Right, so in default it will return you the first 5 rows, right? Now if you say no, I want to see the first 10 rows, how can you do that? Just need to do data.head, then you can specify the number, the first 10 rows or the first 15 rows you want to see. You will get total that many of 0 to 14, that many of data set, that many of rows, right? So this is why we use .head. Now comes data.tail. Why do we need to use data.tail? Data.tail will give you the last 5 rows of your data set. I hope you get the difference between head and tail, right? So then, as the name suggests, basically tail will give you the first 5 rows of your data. Now let me just execute that. Yes, this is what you get. The last you have 768 total columns you have, total rows you have. Now I want to see all the 9 columns we have talked about, only the columns. How to do that? You have to write you have to write data dot columns. So the columns will return you all the column you have in your data set. You have column called pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetic predictive function, age, outcome. Right? So this is what you get after you write data dot columns. Now I just want to talk about what is my data shape. So total columns I said 9. How many rows we have? In order to get that, you have to write data dot shape. So after you write data dot shape, you will get the total shape of your data. That is 768, 9. So total rows you have 768 and columns you have 9. Alright, so we have already talked about this data dot hit. Now we will see how can we treat the missing value detection treatment. In this part, we are going to do the missing value detection and treatment. So how can we do that? So in this case, how can we understand we do have missing value? The following value in the data sets are considered to be missing values. Suppose you have blank values or you have null or some continuous columns might have zeros to indicate missing data. This is where we can understand this particular that is having a missing value. Now, how can you get that? Let's start by checking the count of the records in each column of the data set. So, if the count of the record is lesser than the total number of records, then suppose 768, we can conclude that there are blank records, right? I have written data.info, right? Can you see what I get? The count of the records for all the columns is 768. This indicates there are no blank columns in the data set. Yes, you do not have any blank column. Now, if I just want to understand, do we have any null value? How to understand? We can use a function called isAny function. This isAny function is used to understand, do you have any null value in your data set? Right? Let me just execute that. What it's going to return? It's going to return that true or false, right? If you don't have any null values, then it will give you like false. But if you do have, it will give you true, right? Suppose you have written data.isAny.any. For each and every column, it's going to give you, do you have any null value for this particular column? So in the case of pregnancy, you said no. It said basically no. For glucose, it said no. Blood pressure, skin thickness. For any of the column, we do not have any null value. Now, if you just want to get the summation of the null value, right? So there is an option. We have data.isAny.sum. So it will give you total number of value, like total number of null value you have in every column. So you can see for all the column you have 0, 0, 0. That means you do not have any null value. Since all the predicted columns are continuous in nature, there might be a chance that zeros in these columns indicates missing values. Let's say, do you have any 0? So if I just write data.describe, what is describe function? A describe function from the, it's going to give you what is total count of the data, what is the mean of your data set, what is standard deviation, then what is minimum value, then your interquartile range and the maximum value. Now, if you look closely, you can see the minimum value for pregnancy is 0. That can happen. The glucose is 0. Will that possible that a person has a 0 glucose? No. A person can have 0 blood pressure. No, it's not gonna happen. Skin thickness 0, insulin 0, BMI 0. It's not possible even. So you actually have null values, or that is nothing but representing as 0. Let's see what I have written here. From the above description of the data, we can see that columns pregnancy, glucose, blood pressure, skin thickness, insulin and BMI have minimum value of 0. It makes sense to have 0 pregnancy, but it does not make sense for other mentioned variable to minimum value of 0. So we can conclude that glucose, blood pressure, skin thickness, insulin and BMI have missing data. that zeros in the columns should have replaced with the median. We always replace with median since the median is least affected by outliers, as we have already talked about outlier. Now, if we just do data of glucose, so basically I just want the column for glucose. I have written that data of glucose, you will get all the data from the Google, from the glucose column, right? Let me just execute that. Okay, now if I just write replacing the zeros with nan, we need to import one particular part from NumPy, that is known as import nam. The records that have zeros in the column glucose, blood pressure, and skin thickness and insulin and BMI will be replaced with nan. To understand how many nan values we have which are hiding behind zero. Right, that's why I have written data of glucose equals to data of glucose dot replace 0 comma np dot nan. So if you want to replace any value in the data set, you have to use replace function. Now I have 0, I want to replace 0 with nan, right? So this is why we use np.nan. Now, if I write data of blood pressure the same way, I have written replace 0 with np.nan, for skin thickness, for insulin, for BMI. Right? You can see this is how we can do this, is replacing 0 with np.nan. Now, if I write data.head, so this data dot head will give you the, like suppose you have 0, you can see in insulin, normally you can see for the first 3 record has nan value. For skin thickness has nan value. So basically these were replaced, like the zeros were replaced with nan. Now if I just write data dot describe, you can see there is minimum value for glucose is 44, for blood pressure is 24. So we do not have any zero values because as they are already replaced with nan. So this is how you can find it out your missing value. But finding out missing value is really problematic, and also you need to keep your mind working. As I said, working with data is easy, but understanding data is not easy. You have to first understand data. You have to make sure what are the information you are getting from data, it's worthy of getting, right? So these are the things you have to keep in mind while you are talking about the exploratory data analysis, which is nothing but again our module name is anomaly detection or outlier detection, right? So I have written data.isNull.sum. So you can see total number of null value we have, we will get the summation of that. So for the case of Google, we have 5 null value. Sorry, for the case of glucose, we have 5 null value. And the case of blood pressure, we have 35 null values. In the case of skin thickness, oh my god, for 227, and for insulin we have 374. You can see how many mean value, like how many missing value we had, and which was just hiding behind zeros. For BMI we have 11. Right, as in for 2 column glucose, blood pressure, skin thickness, insulin and BMI have missing data. Glucose, blood pressure and BMI have less number of missing data, while the case of skin thickness and insulin have the high or very high amount of missing data. Now, removing this missing data from the data set will result in information loss, and it is not as advisable to remove these records since we have only 768 records. Hence, we will input this missing value with median of their respective columns. Since median is the least affected by outliers, we will replace all the nan value with median. Right? This is how we are going to handle missing values. Right? Please do let me know if you have any doubt about missing value, about outliers, about whatever we are talking about. Right? So I will happily help you and help you to solve your doubts as well. Now, if you just write data.median, this median value or we know how median works, right? So just by calling the function median, it will give you the median for each and every column you have. So for pregnancy, median is 3, glucose is 117, for blood pressure is 72, For skin thickness, we have 29. For insulin, you have 125. For BMI, you have 32. And for diabetes predictive function, you have 0. And for age, you have 29. Right? So this is how your median function is going to work in your whole data set. Now, what we need to do? We need to import, or we need to not import, we need to fill our NaN values with data.median. How can you do that? Inputting missing values with their respective columns, median, and to fill NaN value, we need to use a function called .fillNA. So we have written data.fillNA. What you need to fill? Data.median. So your value will be data.median and in place equals to true. All right. Let me just print data.head. So can you see your skin thickness is replaced. Your insulin that we got, that NaN value, this 125.0, 125.0. These first three columns are replaced with median. So you will not have any data loss. It is actually recommended not to delete the data or not to cut the data. If you have a huge data set, maybe you can go for, while you have just 768 data set, this is not recommended to remove the data with NaN value. Except like this, you can replace NaN values with median. Right? Now we are going to check if the missing value have been imputed or not. How to do that? We just need to again use data.isNull.sum. Why to use .isNull? We use .isNull and sum to check how many null value we have in our data set. Can you see? Now we just have 0 null values. Right? In the next part, we are going to talk about how can we handle outlier detection and how can we treat them. Right? I hope you have all understood about missing value. If you do not know in the normal way that you have missing value, then now you have to go deep and you have to investigate little more to understand, do you really have missing value or you don't? If you have missing value, then go and remove them if you have a big data set. If you do not have big data set, then replace them with median. And after that, you are ready to use your data set, right? So this is what missing value, treatment works for and how can you find it out. Then in the next part, we will talk about how we will find it out, outlier detection, and how can we treat them. Now, in this part, we are going to talk about outlier detection. I know you all have idea about outlier detection, right? Now, we will talk about outlier. Outliers are extreme values that deviate from the other observation on data. They may indicate a variability in the measurement or experimental error or novelty. Box plots are a great way of detecting outliers. We already talked about box plots, right? So yes, it will help you to find it out the outliers. Once the outlier have been detected, they can be imputed with the 5th or 95th percentile. We will talk about that, how to do that. So how can I do that using box plot? You have to write plt.figure to make your figure size. Now you will go for plt.subplot. In one plot, there will be subplot you want, right? So you have written 441. Now we are going to use CBON and I have given CBON as SNS. So SNS dot box plot and data of pregnancy. So for the pregnancy column, you just want to plot the box plot. Now in the case of glucose, you will again write plt.subplot 442. Can you see the number are changing that where you want to place this particular box plot? Now I have written is dot box plot, then data of glucose. Then move further, we have plt dot subplot 443 and SNS dot box plot data of blood pressure, right? So for again we will going to write plt dot subplot 444 your data place where you want to put your box plot, and I have written data of skin thickness. The same way we have done for data insulin, we have done for BMI, diabetes predictive function, and age, right? So it's going to give us the box plot. Now, if you don't know box plot, then I should suggest please check the previous part of the video where we have talked about box plot. Now, in the case of pregnancy, can you see there is a 3 dots? So basically, it's showing there is outlier. In the case of glucose, you do not have any outlier. In the case of blood pressure, you again have outlier. In the case of skin thickness, obviously you have outlier. Age has outlier, diabetes pedigree function has outlier, insulin has lots of outlier, and BMI also have the outlier. Now, if I go for the observation apart from glucose, all the other attributes shows the presence of outliers. This lower level and upper level outliers will be replaced by the 5th and 95th percentiles respectively. Right? Now we have talked about IQR. What is interquartile range, guys? Let me know in the comment section. Again, for your WhatsApp, for your heads up, that the interquartile range, that IQR, is a measure of variability. Based on dividing a dataset into quartiles, quartiles divides a rank order dataset into 4 equal parts that we have talked about, which the parts are known as quartiles. So the value that divide each part are called as first, second, third quartile, and they are denoted by Q1, Q2, Q3 respectively. Now what we are going to do, we are going to, that we have talked about interquartile range. Now what we are going to do, we are going to write numpy dot clip function. So the numpy dot clip function will help you to clip our data as we have outlier, right? So what is how to use clip function? So if this clip function, you need to give the limit, the values in an array. Syntax numpy dot clip, and the parameters you have the array containing elements to clip, you want to clip. Then minimum value, if none clipping is not performed on lower interval age, not more than 1 of a underscore mean, and a underscore max may be none, and a max is nothing but your maximum value, right? Now if I just need to clip, what I need to write, I have written data of pregnancy. You want to work on the pregnancy column, then I have written data of pregnancies dot clip. I want to clip my data. Now what I need to do, for the lower limit, I am going to give data of pregnancy dot quartile 0.05. Then we have written that upper will be data of pregnancy quartile 0.95, as we have talked about here, right? That the values divide each and that not. So yeah, this lower and upper level will be replaced by 5th and 95th percentile respectively. So your 5th quartile, 5th percentile and 95 percentile, while it comes to upper, and then while it comes to lower, right? This is lower, right? So this is how we can do that. Now let me do that. Okay, now I have written data of blood pressure and data of blood pressure dot clip. Again, you are going to clip the blood pressure column data. For skin thickness, yes, you are going to again clip skin thickness. For insulin, you will clip insulin. You will clip BMI, diabetes pedigree function, and age, right? Wherever we have seen this particular, outlier. Then what we need to do, we again need to plot our box plot to understand, do we have again any outlier in our data set? If we have, how can we, replace them again with the clip function to clip our data to remove outliers, right? So we are going to write plt.subplot the same way 441, then SMS.boxplot, and then for pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and age. Right? Can you see? For the case of pregnancy, again, you do not have any outlier. Glucose, blood pressure, skin thickness, age, diabetes pedigree function, and BMI are fine. For skin thickness also, you have a little outlier, right? So skin thickness and insulin is not worked out, right? As we can see, there are still outliers in the column called skin thickness and insulin. Let's try manipulating them with the percentile value. Now we will try to do heat and trial. Now we have written that again we are going to clip, and quartile will be 0.07 to 0.93. Let's see how it's going to work. And for insulin also, we have written 0.21, the lower one, and the upper one we have written 0.80. Now if I just plot both of them, okay, insulin has insulin didn't work, but skin thickness has worked on. Now let's manipulate insulin little more. I have right quartile equals to 25% for the lower, and the upper will be 0.75%. Now if I just plot it, can you see your insulin is also worked and there is no outlier for your insulin. So this is how we can actually help to remove outliers from the data. The outliers of data skin thickness were treated by minor changes in the percentile, but the outer layers of insulin require a major changes in the percentile. This might result in too much data manipulation, which might again, it's not good for your model. Attribute insulin might have to be removed from the data set. It will give you good value, because as you have to manipulate your insulin for so many times. So this is what missing value and outlier analysis stands for. Now after this part, we will talk about data visualization. How can you visualize our data using Matplotlib and Seaborn? Now we are going to see how can we do the data visualization. But what are the things we have done so far? We have talked about how can you understand data using pandas. Then we will jump into how can I see that my data is already uploaded. Then we have used pd.readcsv. Then we go for understanding missing value and basic terms to understand your data like describe, info and all. Then we have talked about missing value. How can I find it out? Missing value. Maybe in the simple case, you will not get any missing value. You have to go and deep dive and need to see, do you really have any missing value or not? If you don't have any missing value, then it's fine. If you have missing value, you have to make sure that you are those missing value are treated. Then we go for outlier analysis. So it's basically trying to understand, do we have any error in our data set or any anomaly? If we have outlier, we will try to replace them using interquartile range, right? Now we will do the data visualization. Now we are going to use sns.countplot. So we just try to understand what is the data set we have, where how many people are diabetic, how many people are non-diabetic. Right, in that case, we are going to use outcome column. As I said, outcome is 0 means the person is not diabetic. Where your outcome is 1, then it's showing that your person, the person is actually diabetic. So you have written data sns.countplot. This sns.countplot is basically give you the total count of your data for 0 and 1, the different class we have. Now in the case of count, you can see 0 is high, 1 is low. So 0 means the more person you have is non-diabetic and 50% of the person you have diabetic, right? So this is where the sns.countplot stands for. We have already talked about countplot, right? Why don't you guys see what are the things we can do using this particular data set where we can use countplot, right? Now we will see the observation again. From the above plot, we can infer that the majority of the data consists of non-diabetic patient. Let's try to understand the percentage distribution of diabetic versus non-diabetic in the data set. Now what you have written? You have written total equals to float and then length of your data. A little bit of programming we have done here. Now you have written ax equals to sns.countplot and your x equals to outcome and data equals to data set you have. For p in ax.patches height equals to p.get height. ax.text p.get underscore x plus p.get underscore width divided by 2. Height plus 3, right? Why do we have done those things? To get the percentage of the data. you can see the 65% of the data contains records belonging to non-diabetic patient, and the 35% of the data is saying you have a diabetic patient. The dataset has a class imbalance and might have to be treated in future during the model building stages. While you try to build a model, maybe logistic regression, we will talk about linear regression analysis. We will talk about machine learning as well. But yes, if you want to model, you have to make sure you are going to use the class imbalance technique. Not now. You need to don't know about it. But yeah, these are the things. It's as suggested. Now we will see if we will do a correlation. What is correlation? So let's now plot a correlation plot. That is like, this plot will help us understand if there is a multicollinearity in the data set or not. So what I have written f comma ax. Again, we are going to understand this figure size, that plt dot fixed size equals to 20 comma 10. Then for correlation, you have to just write data dot correlation, what type, Pearson. Now you have written SNS dot heat map and then your correlation, right? So you will get what? You will get this correlation 1. Can you see correlation with pregnancy? And pregnancy, it will be always 1. That's why diagonally, all the index you have, that is 1. Right. This is something like the, read part is the morely highly correlated. Right? Now, from the above correlation, it can be inferred that there is no high multipolarity in the data set. The correlation plot shows the relation between the parameters. Glucose, age, BMI, and pregnancies are the most correlated parameters with the outcome. Insulin and diabetes predictive function have little correlation with outcome. Blood pressure and skin thickness have tiny correlation with the outcome. There is a little correlation between age and pregnancies, insulin and skin thickness, BMI and skin thickness, insulin and glucose. Right? Now we are going to work on pair plot. Right? And this is what we are going to do, and that's all for our data visualization. What is pair plot? Pair plot is a pairwise relationship in the dataset. If you want to see pairwise relationship, the pair plot function creates a grid of axes such that each variable in the data will be shared in the y-axis across the single row, in the x-axis across a single column. Now to get the pair plot, I have written SNS dot pair plot. Data u equals to outcome, and how we are going to do a pair plot. But working on pair plot, it takes time. Why? Because pair plot is making pair plot each and every columns you have. Right? Let's see how it's going to work. We will see about pair plot. Let's see how it's going to work on pair plot. So I hope you guys have understood all the technique we have done so far. If you have any doubt, do not forget to let me know in the comment. I will happily help you to solve your doubts. And if you like the video, do not forget to like it and subscribe. Great learning. So can you see, this is what the pair plot we get. Now, what I want to understand from the pair plot, what are the things we can conclude? We can infer that the most of the predictor variables are weak predictors of outcome. The kernel density plots, the diagonal suggests that the distribution for diabetic and non-diabetic are very similar and are overlapping each other significantly. Hence, they won't be able to differentiate between a diabetic patient and a non-diabetic patient. The scatter plot also suggests very poorly correlated data with not hidden patterns or relationship. Hence, model built on this data might not be able to find out any hidden patterns or might identify nonsense patterns that do not make sense. The plot shows that there is some relationship between parameters. Outcome is added as hue, that variable. What is hue? The variable in data to map the plot aspects to different colors. We see that blue and orange dots are overlap. Pregnancies and age have some kind of a linear line, and blood pressure and age have the linear little relation. Most of the aged people have blood pressure. Insulin and glucose have some relation. This is what we can actually conclude from the player plot we have done. Right? I hope you understand how to do a anomaly and outlier detection. How can you make sure that you are making sure that whatever the exploratory data analysis you are doing in your data, it's giving you enough insights to work with your data. Right? This is what we have done about this particular diabetes data set. Now, in this part, we are going to do one more exploratory data analysis on different data set. We have done exploratory data analysis, outlier detection in diabetes data set. Now we are going to use automobile data set. Where you will get the data set? You will get the data set on www.kaggle.com. Just click on the link, you will redirect to this particular data set. It's a free data set and you will get this data set on Kaggle. Now, if you want to download this particular data set, just click on download and it will automatically start downloading, right? So this is pretty much about the data set where you will get the data. Now let's talk about the dataset description, right? So in 1985, model input car and truck specifications, and 1985 words automate yearbook. So personal auto manuals, insurance service office, 160 Water Street, New York, NY 10038. Insurance collision report, Insurance Institute of Highway Safety, Watergate 600, Washington, DC 20037. Right? So this data set consists of three types of entities, right? What are those entities? So basically entities is nothing but the columns we have. And the specification of an auto in terms of various characteristics. B, it's assigned insurance risk rating. It's normalized losses in use as compared to other cars. The second rating corresponds to the degree to which the auto is more risky than its price indicates. So cars are initially assigned a risk factor symbol associated with its price. Then if it's more risky or less, this symbol is adjusted by moving it up or down. The scale. Actuarians call the process symboling. A value of +3 indicates that the auto is risky and -3 that is probably pretty safe. The third factor is the relative average loss payment per insured vehicle year. This value is normalized for all autos within a particular size classification. Two-door small, station wagons, sports or specialty etc. and represents the average represent the average loss per car per year, right? So I know this is a little complicated while we are talking about the dataset description, so let's talk about more in depth in the dataset. So if you do not know how to upload the data, you have to just click on this particular button, and from there is an option for upload the station storage we have talked about before as well. Just click over here, it will redirect to you to your local system, right? And this is how you can upload your data in the station storage. My dataset is automobile_data.csv. Now I have imported few packages. I have imported pandas, numpy, cpon and matplotlib. So a quick a question for all of you: why do we use cpon and matplotlib? Please let me know in the comment section, and if you like the video, do not forget to like it, and if you want to get updated with the new content, then do not forget to subscribe. Great learning. Right? So how can you load the data set? You have to use a function called .read_csv. We have talked about that before as well. But as a recap, just to remind you, so we use .read_csv function to read CSV file. So I have written automobile_data.csv. Right? Now, okay, I forgot to install this. Importing these libraries. Okay, now if I just write it, yes, it gets executed. Now if you want to see the first 5 rows of the data, how can we do that? We just need to write data.head, right? Let me do that. Now if you want to see the columns in your data set, how can you do that? You have to write data.columns. right? I have written data dot columns. Now, if you want to see the shape of your data set, how can you do that? You have to write data dot shape. So it will give you the total shape of your data, how many rows you have, how many columns you have. Let me do that. Right. Now, I want to see the first 10 rows of my data. What I need to do, I have to write data dot head, and under the parentheses you have to write 10. Otherwise, in default, it will give you 5 rows. So here it gives me 10 rows, right? Now, if I want to see the last of the data, from the last, if I want to see the rows, I have to write data dot tail. What it will return? It will again return the 5 rows from the last from your data set, right? So total data, how much you have? 205 data. So as it counts from 0 to till 2043,210, you got the last 5 rows of your data. Now, if you want to check, do you have any null value or not? What we need to do? We have to use a function called dot is null. And why we are using any, please let me know in the comment section, because I have already explained that, right? I have written data dot is null dot any. So basically it's going to return, yeah. So if you have any null value in your data set, it will show here. So for all the cases, it's false. So you do not have any null value. Now, why do we use data.describe? It's basically describe few things about your data set. So total count of your data, what is the mean value for each and every column you have, then what is the standard deviation, then minimum value you have in the data set. Then if you just want to part your data, that IQR range, right? First part, second part, third part, fourth part. So first quartile, second quartile, and so on, right? So 25%, 50%, 75%. And then you have max value in your data, right? So this is what a data.describe function describe us about the data. Okay, now you can see from the above snapshot of the data, we can see that some columns have missing values. What are the missing values? No, I cannot see here. Okay, right. So yeah, can you see here? This is the maybe you did not get any null value, but you have the question marks, right? Can you see? Okay, if you can see, please do let me know in the comment section. So yeah, can you see we have this? We have to remove this. Okay, so for is null, maybe it's not taking as null value, but we do have few values that's inappropriate while we are going to do this data analysis. Now we have to what? We have to remove them as a missing value detection and treatment, right? So let's start by checking the info, right? The count of the records in each columns of the data. If the count of the records is lesser than the total number of records, so we can conclude there are blank records. So no, we do not have any blank records, right? But the records are representing this. These are the actually blank records, right? Now, since some of the predictor columns are continuous in nature, there might be a chance that zeros in the columns indicates the missing value that we have done earlier as well. Now, if I just try to write data.describe.t, then you can see here the same thing. Right, so here we are saying none of the continuous seem to have a missing value represented by 0. We can also see there are a total of 11 continuous variables, but the describe table has only 10 continuous variables. This is because of column normalized losses has missing values, right? So here, how can we do that? So here we can see we are going to use numpy. So we have written from numpy import nan. And data of normalized losses equals to data of normalized losses dot replace that question mark, comma. I want to replace the question mark with np dot nan value. If I just do that, and then if I just do the data dot head, you can see we do have nan values. These are the different way you can understand you do have missing value and you have to handle them with care. Right, now you have to write data dot head if you want to see again. Now I want to see something, that data dot is null dot sum. Now I will get the actual sum of the null values. So for normalized losses, we have 41 null values, right? So normalized has 41 missing data points, and we will replace this missing values with the median of normalized losses because median is least affected by outliers, right? So if I just write data dot fill any data dot median comma in place equals to true, right? So I want to fill my nan values with the data of median. Now if you want to see what is median differently, let me show you. I have shown it in the previous project as well. Let me just show that. Okay, data dot median, it will give all the median value for each and every column you have. So for normalized losses 115, it will automatically replace those with the 115. Let me show you. Yes, can you see all the nan values are replaced with median? This is how you can actually replace your nan values, and how can you treat these missing values. Now if I try to see data dot is null dot sum, then it will give me 0, that we do not have actually any nan values. Now if I just don't want to go for data dot info, right? So now what we need to do, so you can see over here that notice that the data type of normalized losses is object. We have to change its data type to numeric float. Yes, because we don't want to have a data type of object, we want to make it a numeric value. How can you do that? You have to write data of normalized losses equals to pd dot, right, to underscore numeric, if you want to change something to numeric. And then I have given data normalized losses comma downclass equals to float, right? Now if I just write data dot info, it will show that normalized losses is float 34.2, right? It's not numeric value, we have done it, right? Okay, what is this? Okay, right. So now if I just do the info, it's done, right? Now that we have treated the missing value, let's move to the outlier detection and treatment. Now we will see how can we do the outlier detection. So outlier detection is basically, we can find it out by using box plot, are a great way to detecting outliers. Once the outliers have been detected, they can be inputted with the 5th and 95th percentiles, right? So I have written data dot columns, right? And then we have just done the outlier detection using box plot, right? We have written plt dot figure fixed size 20, 15. Then we have written plt dot subplot 3, 4, 1. So what subplot you want? Like, this is the portion you are giving while you have a plot, and then you have the subplots, right? And your figure size will be 20, 15. Then you have given the normalized losses, symboling, wheelbase, length, width, all the columns you have given to see what are the columns has the outlier. You can see this at the outlier for highway mpg, you have compression ratio, you have engine size, width, otg, mpg, you have the outlier. Okay, few of the columns have the outlier, right? So you can see how the outliers, this dotted are nothing but the outliers you have. Now, like from the above box plot, we can infer that out of 11 continuous variable, 8 of them have outliers. These outliers will be imputed with the, right? Imputed with the 5th and the 95 percentile. How we did? We have used a clip function. So again, for your a sweet question to all of you guys, what is clip function? Why do we need to use clip? Please do let me know in the comment section, for that we can understand you are actually listening to us. If you like the video, do not forget to like it and do not forget to subscribe. Great learning. Now we have written data of normalized data equals to data dot normalized losses. Okay, clip lower data dot quantile 0005, upper is equals to quantile 0.95. Let me just do the for all the columns we have, and then we are going to again plot the box plot. Can you see all the columns have no outliers? So you have successfully handled the outlier we have in the data set. Now you can see you can go forward with the data. Now we will do few data visualization. What are those data visualization? We try to understand the pair plot. How can we do that? We have written sns.pairplot. What is sns.pairplot data, and then it will give you the pair plot. Pair plot is nothing but giving the relation between different columns you have, right? So let it get printed. Let's see. Let's wait for a few minutes, and in the meanwhile, if you have any doubt, please do let me know in the comment section. For that, I can help you out to solve your doubts as well, right? Let's see. Okay, it's coming. Seaborn. And pair plot we are using from Seaborn, so that's why it's sns.pairplot. As the data set is little bit big, that's why doing the pair plot, it's taking little much of time. Okay, so it takes a little bit of time, but you can see this is what it's showing, that you get the pair plot, right? Okay, so some of the kernel density estimate plots show more than one peak and indicating the presence of clusters in the data set. So basically, maybe you have clusters in the data set, right? Now, if I just want to go for correlating data, like understanding the correlationship between different columns we have, we use data.code, that's Pearson, and then we have used the sns.heatmap. So this heat map is nothing but your correlation between different columns you have. So with symboling it's one, you can see, and this is the it's more of a rate. This is the more of like your columns are correlated, right? So the above correlated plot shows presence of multicollinearity in the data set. You can see there are multicollinearity we have in the data set, right? And if you just want to go for few understanding few visualization, how to do that? So I just write data.symboling.histogram. I want to understand the histogram. Then I have given the title as insurance risk rating of vehicle, number of vehicles, risk rating. This is the risk rating according to the vehicles, right? From the above histogram, we can infer that a major part of distribution lies between the range of 0.5 to 1.5. We can also infer that a large number of cars in this dataset are safe. Obviously, cars are mostly safe. Now, if I just want to understand the frequency chart, then fuel type, that data of fuel type dot value counts dot plot, that kind equals to bar, right? And we have written plt dot title, frequency chart and fuel type, number of vehicles and fuel type, right? Let's see, number of vehicles and fuel type. Yes, you can see this is the number of vehicles, and this is the, like we have gas is more, diesel is less, right? So the above bar chart, we can infer that the majority of the car recorded in these data sets run on gas, right? Now we will do few things about the data set, the data pre-processing. This data set has 15 categories variable, and most of them have more than 2 categories. We cannot run a regression model on the text data. So we actually are going to talk about regression model. You have to keep tuned to know about regression model. And in the meantime, let's see how can you do the data processing. So in the order to deal with this challenge, let's learn about level encoding. Level encoding is the process of converting categorical data into numerical data. Let's see how this is done. In the example, we will be working with the variable body style, which has 5 categories, namely convertible, hatchback, sedan, wagon, and hardtop. Now what we have done, we have just done data of body style, head 20. So I just want to see the 20 data from this particular column. Now we are going to do a label encoding. How to do a label encoding? So basically for each and every vehicle, you will get an idea, you will get a numeric value. Suppose you have the person is diabetic or not, you have 0 and 1. So you have 5 different parts, like 5 different types. So you will have 0, 2, 0, 1, 2, 3, 4. This is what stands for label encoding. So I have written sklearn, that is scikit-learn import pre-processing, and from scikit-learn pre-processing import label encoder. Then I have just called the label encoder, and just I have given my label encoder.feed transform data of body style. Then if you just write .k20, you can get that what are the thing you have for a particular, suppose you have for convertible, it's converted to 0, then hatchback converted to 1. So for all the hatchback you will get 1, for all the convertible you will get 0, for all the sedan you will get 2. This is how we did the label encoding, right? So after running the label encoding code, we can see the variable body style has numeric values ranging from 0 to 4. The problem with the table encoding is that it introduces an order between the categories, that 0 greater than 1, 1 greater than 2, 2 greater than 3, and 4. This might confuse the model into thinking that convertible is greater than hatchback. So to deal with this problem, let's understand the concepts of one-hot encoder. In one-hot encoding, categorical columns have been labeled encoded are split into multiple columns, and the values are replaced with zeros and 1. 1 marks the presence of value and 0 its absence. Right? Let's look at the example. So I have done this particular label encoding, and then now I'm going to go for one-hot encoding. So again, to import one-hot encoding, I am going to import it from scikit-learn. And then I have called one-hot encoder handle unknown equals to ignore. And then I have given my dataset to transform. Now, if I just want to show you what's happened, can you see you get 1, 0, 0, 0. So you have total 4 class, right? Total 5 class, 0, 1, 2, 3, 4. So if your class comes under 0, it will be 1. If your class comes under 2, it will give 1, and other than everything will be 0. So there will be no like 0 greater than 1, 1 greater than 2. These concepts will not be there. That's why we went for one-hot encoding. Right, so this was pretty much about the data pre-processing. We have done the data visualization. How can you handle outlier? How can you handle like different multicollinearity, and also like how can you find it out multicollinearity in the data set, and how to do the outlier analysis as well using box plot. Right, so we have talked about everything in the both of the dataset. I hope you will like it.
I would like to start off today's session. So we'll be starting with this library called as pandas, which stands for panel data. And if we want to do any sort of data manipulation or data wrangling on top of a table, then this needs to be our go-to library. So as it is stated over here, so pandas would provide us single dimensional and multi-dimensional data structures, and the single dimensional data structure is known as the series object, and the multi-dimensional data structure is known as the data frame. So we'll start off the single dimensional labeled array, which is the series object. So if we'd have to work with the pandas library, we'll have to start off by importing the pandas library. So we'll type import pandas as PD. After we import it, we'll have to create the series object. So we'll have pd.series, and inside this, we will be passing in a list. So here, as you see, I am passing in a list of values starting from 1 going on till 5. And that I am storing it in this new object called as S1, and I print it out. So if you see over here, I have all of these numbers, and we have the indices for these numbers over here. And in Python, you'd have to remember that the index value starts from 0. So element 1 is present at index 0, element 2 is present at index 1, element 3 is present at index 2, and so on. And after I create the series object, when I look at the type of this, you will see that, so type of S1, you will see that this is pandas.core.series.series, which is basically a series object. So I'll actually quickly head on to Jupyter Notebook. Let me open up Jupyter Notebook over here. So this is how Jupyter looks like. I'll just open up a new Python file over here, and I'll start off by importing pandas. I'll have import pandas as PD. Then going ahead, I'll just wait for a couple of seconds for this library to be loaded. So when you're loading Jupyter Notebook for the first time, it might just take a bit more time. In the meanwhile, I'll just write the next set of commands, so pd.series, and inside this I'm passing in a list of values. So I'll have 1, 2, 3, 4, and 5, and this I will go ahead and store in an object called as s1. Now if I print out s1, you will see that this is the result which I get. Now after this, if I would want to check the type of this, so inside the type method I will be passing in the object s1, and you would see that this is what I get. So we have created the series object. Now after this, so as you see, we have the indices over here, and if I would want to change the index values, so by default the index values which you get are numeric and the initial value starts from 0. But if I don't want it like that, if I want to give some other index values, then in that case I can just add this attribute called as index, and I will pass in a list of new indices which will be replacing these old set of indices. So here what I'm doing is I'm giving these new set of indices which are A, B, C, D, and E. So I'll just show you guys how it's done. I'll copy the same command, I'll paste it over here, and what I'll be doing right now is I'll add this attribute called as index, and inside this I'll be passing in new set of indices. So I'll have A, B, C, D, and E. So 1, 2, 3, 4, 5, and I have 5 labels over here. Then I'll print out S1. Let me print this out, and as you guys see, this is what I get. So I have the series object where I have all of these values, and these are the indices corresponding to these values. So earlier we had created a series object from a list. Now let's see how to create a series object from a dictionary. So dictionary, you can consider it to be a data structure which comprises of key value pairs. So as you see over here, inside this we are passing in this dictionary where we have the set of key value pairs. So here we have A, 10, B, 20, and C, 30. So A, B, and C are the keys, 10, 20, and 30 are the values. Let me head back over here. So pd.series, I'll have this. Let me give in the first key. So first key value pair. Then I'll have B20. After this, I'll have C30. And this I'll just go ahead and store in a new object called as S2. Now if I print out S2 over here, you will see that the keys become the index and the values over here become the values of the series object as well. So this is what happens if you try to create a series object from a dictionary. Now once this is done, we will again try to add or change the index values. So as you see, here we have A, B, and C as the initial index values. Now what I'm trying to do over here is I am trying to add one more index value. But the problem is initially we have only 3 keys and 3 values. But when I'm adding this parameter called as index, and over here I'm providing 4 keys. So, and also if you notice, I am changing the order of the indices. So what happens over here is initially the sequence will be A, B, and C. But since I'm changing the order, I'll have first B20, C30. I don't have a key called as D over here when I'm creating the series object. So that is why I'll have NaN, which basically means a null value over here. Then I'll finally have A, and the value for A will be 10. And when I print it out, this is the result which I get. So let me copy this again. I'll paste it over here. And this time, again, I'll be using the index attribute. And over here, let me just pass in a couple of index values. So I'll have B, then I'll have D, then I'll have A, then I'll have C, and let me print out S2 over here. And as you see, I have changed the sequence of the elements which are present. So now that we have created a series object, if I want to extract individual elements which are present in it, so let's say if I have this normal series object where I have indices like these, I'll print out S1 again. And let's say if I want to extract the second element. So the second element is present at index number 1. So what I'll do over here is I'll write S1 and inside parenthesis, I'll give in 1. And as you see, I'm able to extract the element number 2 from this. If I'd want to extract the last element, so for last element, the index value, we'd have to give in -1. So seems like we have an error actually over here. So maybe instead of -1, what we'll do is we'll just give in 4 over here because that will also work. So as you see, when I give in the index value of 4, I'm able to extract the last element from this. So this is all about your single dimensional data structure, which is a series object. So a data frame gives you rows and columns. So you have data in both the dimensions. Now, a data frame, if you have worked with SQL or Excel, then you can consider this to be a table format. And if you'd want to represent or work with table formats in Python, the analogous format will be a data frame. So here we are creating a data frame from a dictionary. So first again, we'd have to import the pandas library. And after we import the pandas library, here I am creating this data frame by using pd.dataframe method. And here you'd have to keep in mind that the D and F are capital over here. So let's say if you give either the D or F as small or both of them are small, then you will get incorrect result or you'll basically get an error. So pd.dataframe, and inside this I'm passing these key value pairs. The first key is name and I'm giving a list of names for that. Then the next key is marks and I'm passing in a list of marks over here. So now if you look at this dictionary, you will see that the keys become the column names and the values become the records over here. So name is the first column and Bob, Sam and Annie become the records. Then we have marks, which becomes the second column, and these list of values become the records over here. So now if I go back, what I'd have to do is, since I actually have pandas imported, I don't have to import it again. So I'll just directly write down pd.dataframe, and inside this I'll just pass in a dictionary. So first I'll give in the name of the column, which is name, and then I'll pass in a list of values. So actually name, maybe I'll give in the first name as Raj, the second name as Howard, the third name as Sheldon, and I'll have the second key over here. So the second key would become marks, and then I'd have to pass in a list of values for this. So let's say Raj has scored 70 marks. Then we have Howard, who has scored 80 marks. Then we have Sheldon, who has scored 90 marks. Now I'll just click on run and you'd see that this is what I get. Let me actually store this in a new object and I'll call that object to be df. I'll print out df over here and this is the result which I get. So this is how a data frame works. Let me actually show you the type of this. So I'll have type of df and I will hit on run and you would see that this tells you it is pandas.core.frame.dataframe, which essentially means that this is a data frame object. So this is how you can create a data frame. Now let's see some methods on top of this data frame. So for this, now what we've done is we've actually created a data frame, but mostly in Python, if you'd have to work with some inbuilt CSV files or inbuilt tables, you can directly read them using this pandas library. So for this, now whenever we talk about a CSV file, what is a CSV file? CSV stands for comma separated value. So all of the Excel files which you have, they're mostly stored with the extension .csv, and we'll be loading them up with the help of this pandas library. So I have this CSV file in my Jupyter notebook called as iris. So I'll start off by loading that particular file. So I'll write down pd.read_csv, and inside this I'll have iris.csv, and I will store this in an object called as iris. So now once I store this, I'll look at the head of this. So head is something which will give me the first 5 records of the data frame, and I'll hit on run. So now this method will help me to load a CSV file. I've loaded it and I've stored it in the iris object. Then the head method will help me to look at the first 5 records, and this is what I'm doing. So this iris data frame comprises of these columns. So we've got sepal length, sepal width, petal width, and species. And this basically denotes the different species of the iris flower. So you've got the setosa, virginica, and versicolor species for this iris flower. Now, similar to the head, so initially the head method gives you 5 records by default. Now, instead of the 5 records, if I would want to look at the top 10 records, I'll just give in the value 10 inside the method, and you will see that I have extracted the top 10 records from this. Now, a method which is analogous to the head method is the tail method. And here what I'll be doing is I'll write down iris.tail, and inside this I will just pass in or I can just directly hit run, and you would see that I've got the last 5 records. If you look at the index values over here, the index value starts from 145 and it ends at 149. So we've got the last 5 records. So we've got the last 5 records from the iris data frame. And similarly, if I want to get the last 10 records, I'll just pass in the value 10 over here. And you would see that I've extracted the last 10 records. Then if I want some basic information about the different numeric columns which are present, so what I'll do over here is I will write down iris.describe, and when I hit on run, you'll see that I've got all of these information about these different numerical columns. So let's say if I want to find out the mean sepal length, you can directly find it over here. So the mean sepal length is 5.8. Similarly, the minimum sepal width is 2. The maximum petal length is 6.9. The standard deviation for the petal width column is 0.76. So this is some interesting, there are some interesting pointers which you can directly find out by using the describe method. Then, if I want to know how many rows and how many columns are present in this particular data frame, I can use the shape method. So I'll write down iris.shape, and as you see, I get the values 150, 5, which will tell you that there are 150 records and there are 5 columns. So this is a brief info about the pandas data frame, pandas library. So with the help of Matplotlib, you can create all of these different geometries. So you can create a line plot, a scatter plot, a bar plot, a histogram, and so many of the other geometries. So first, what we are doing over here is to create the data, we'll be importing another library, which is NumPy. So NumPy is something with the help of which we can do a lot of numerical computation. So we'll be importing that. So we'll write down import NumPy as NP. Then after that, what we are doing over here is we are importing the matplot library. So I'll write down from matplotlib import pyplot as plt. So here pyplot is a submodule which is present in matplotlib, and I am giving this an alias of plt. Now once I load the required libraries, I will create the data over here. So first I will have x is equal to np.arange, and np.arange will help you to create a NumPy array where we have values within a particular range. And I'm setting the range limits over here. So the range limits are 1 and 11. And you'd have to keep in mind that the initial limit is inclusive and the final limit is exclusive, which means that I'll have values starting from 1 and going on till 10. It will not include 11 because 11 is exclusive. So here I'm creating the data for the x-axis, which I'll have over here. Then to create the data for y-axis, I'll just multiply this with 2. So 2 into x. And now 1 becomes 2, 2 becomes 4, 3 becomes 6, and so on. And then I'll just go ahead and plot this out. So here I will have plt.plot. Inside this, I will pass in x and y, and I'll just write down plt.show. And as you guys see over here, I will have a straight line for this. So let me load all of the required libraries. So I'll write down import NumPy as np from matplotlib import pyplot as plt. Again, let me just wait for a couple of seconds. So we have loaded these two. I'd have to create the data now. So here x is equal to np.arange, and inside this I'll pass in 1, 11, and I'll print out x over here. Then I'll have, let's say, y, and y will just be 2 times of x. This is what I'll have over here. I'll also print down y, and now I have values for x and y. I can directly create the plot. So I'll have plt.show. Inside this, I will pass in x and y. I'll have to show this out, plt.show. This is actually plt.plot. And then I'll have plt.show. Now let me run this. And this is what we get. So now the problem is we've created this plot, but it's extremely bland. We don't have much information for this plot. So I will add a title, x-axis label, and y-axis label for this. So I'll have plt.title, and I'll add the title as line plot. I'll add an x-axis label, so I'll have plt.xLabel, and I'll set the x label to be x-axis. Then I'll have plt.ylabel, and I'll set this to be equal to y-axis. And as you see, I've assigned a title, the x-axis label, and also the y-axis label. So this is how we are creating this line plot. Let's directly head on to our case study for today's session. So we've got this cricket data set where we have all of the information about the different matches which were played till 2019 World Cup. So we will be analyzing all of those data. So Narasimha is asking where is the data set from? So we've taken this data set from Kaggle. So if you'd want any of these open source data sets, you can take them from Kaggle, and that is where we take most of the data sets which we use for our sessions. Right. So coming to this case study, I'll just quickly import the required libraries. Now, once I import these, I have a certain, I have different data sets which I'll be working with. So I've got all of these different CSV files, World Cup players, ground averages, batsman data, bowler data, ODI match totals, and so on. So now the one main data set which I'll be working with is this. So I've got this ODI match totals.csv, and I'll be loading this by using pd.read.csv, and I'll store it in this object called as ODI total. So now that I've loaded the required library, what I'll do over here is, let's say I also have this data set called as World Cup players.csv, and I'll be loading this as well. I'll start off by having a glance at all of the players who are present over here. So if you see, this players.head comprise of these three columns. I've got player ID and country. So player, we've got the player name, we've got the unique ID for the player, and the country for which this particular player hails from. Then, as you see over here, initially head only gives you the top 5 records. Let's say if I give in 10 over here, I'll get the list of these 10 players. So these are the 10 players who constantly played. So all of these data sets, they have data starting from 2013 going on till 2019 World Cup. So throughout these years, these were the list of cricketers who have consistently played for Afghanistan team. Now, let's say if instead of head, if I give in tail, let's see what do we get over here. So we've got West Indies, and all of these are the players who've played for West Indies. You've got Fabian Allen, Shannon Gabriel, Hetmeyer, Shea Hope, Evan Lewis, and so on. So information about all of these players. And now, from this particular list, so as you see over here, so you've got ID, player, and country. If I'd want the list of all of the Indian players who are present in this particular data frame, I can do that with the help of this particular command. So what I'll do is, first I'll give in the name of the data frame, which is players. Then inside parenthesis, I will give in the column name. So here, as you see, the column name is country. And what I'm doing is I'm giving a condition. I'm making sure that whatever value is present in this column, that is equal to India. So now let me actually insert a cell above this and show you how this works. I'll have players. Inside this, I'll have country, and when I set this value to be equal to India, you'll see that I have a bunch of true and false values. Now, wherever you have a false value, it would mean that the condition is not satisfied. And wherever you have a true value, that would mean that the condition is satisfied. Now, these true and false values, what I'm doing is I'm just passing them through the data frame again. So when I have players, I cut this condition out and paste this back into the data frame. This is what I'll be getting. So as you see, I've got the list of all of the Indian players. So you've got Virat Kohli, who's the captain of Indian cricket team, Rohit Sharma, who's the vice captain of Indian cricket team, and we've got all of these players who were part of the 2019 World Cup. So we've got all of this information over here. Now, what I'm doing is I'm just taking this command and storing it in this new object called as Indian players. I'll just have this. And now after we do this, what I'm going to do is I'm going to work with the ODI total data frame, ODI total object which I've created over here. So I'll have a glance at the first 5 records from this ODI total data frame, and I have all of these different columns over here. So this ODI total has different records representing each match which happened between different countries, and you've got all of these different things over here. So this, what you see, this is a match which was played between Pakistan and India, and the score which Pakistan made was 250. So, and who won the match? So if you have 1 over here, it would mean that since in the country column you have Pakistan, this particular match was won by Pakistan. Where was this match played? It was played in Kolkata. What was the date? So date was 3rd January 2013. You've got the country ID. So you've basically got country IDs representing each of these countries. So for Pakistan, it is 7. For India, it is 6. Sri Lanka, it is 8, and so on. And now I'd want to see all of the matches which were played by India. So again, I'll be doing the same thing. This is the name of the data frame, ODI total. I'll pass in this particular column, which is country. I'll set the value to be equal to India, and I'll store it back to the same object, India again. Now I will run this and I will print this out. And as you see over here, these are the different records which I have. And if you look at this particular column, if you look at the country column over here, you would see that all of the values are equal to India. So now, if I look at this particular, if I'll just explain how it is happening over here. So this particular match was, again, so this was played between India and Pakistan, and India had lost this particular match. So if you look at this and this, so this represents the same thing. So India, Pakistan, you have ODI ID. So this is 3315, 3315. So as you see, Pakistan had made a score of 250 and India were only able to make a score of 165. And they had lost the match over here. And then we've got this particular match. So this was between India and Pakistan again. So this was won by India. And even though India scored only 167 runs, India was able to win the match. Then if we look at, let's say, this particular match, so you've got, so let's say the last 3 matches, maybe before the World Cup, India was playing Australia. So India had lost all of those 3 matches over here. So here, even though India made 281, so Australia had made 314, India was only able to make 281, and thus India lost the match. So here, India set up a target of 358 and also lost the match. Here, Australia set a target of 273. India were only able to make 237 and hence lost the match. So, and these matches, if you see, the last 3 matches were played in Ranchi, Mohali, and Delhi. So this is the sort of inference which you get from this. Now, from this entire data frame, if I'd want to extract only those records where India has won the match, you would see that we have this result column. So I'd have to extract only those records where the value in this result column is equal to 1. And that is what I'm doing over here. So India result is equal to 1. And I will store it in this object called as India when. Then I will print it out. And now if you look at this particular column, you would see that all of the values are equal to 1. So now what I'd want to do is I'd want to understand against which opponent have we won the most number of matches. So you've got this opposition column over here. So I'd want to get a frequency count since this is a categorical column. So to understand these categories or to get the frequency of these categories, we'd have this method called as value counts, and that is what we'll be using over here. So India when in this particular so in the parenthesis we'll just pass in the name of the column, which is opposition. Then I will use the value counts method and I will hit on run. So you would see that during this time frame between 2013 and 2019, India has won 15 matches against Sri Lanka, 13 matches against West Indies, and 12 matches against Zimbabwe. Then, rest you have Australia, 12 matches, South Africa, 10 matches, England, 10 matches over here. So now, if I would want to make a bar plot for this, so we have already imported the PyPlot library and we've seen how PyPlot works. So first, I'm going to set the dimensions of the image which I'll be creating. I'll have plt.figure. Inside this, I will set this parameter called as fig size, and I'll set the dimensions to be equal to 8, 5. Now, after this, to make a bar plot, I'm just using plt.bar, and I'll explain this command to you over here. So this takes in all of these parameters. The first parameter is India opposition dot value counts 0 to 5 keys. So till here it's the same thing. So this is the command. Now, if I want to make a bar plot for only the top 5 entries over here, what I'll do is I'll have a parenthesis over here and I'll just give in, I'll set this to be equal to 0, 5. And now if I want only the categories over here, I will use the keys method. So when I give in the keys method, I will only get the categories and I'll not get the values. And this is what I am passing in as the first parameter to this bar, to this plt.bar. Then the second parameter, what I'm passing in is the values. So I'll just remove this dot keys method. And this, when I pass in this, I'll get only 15, 13, 12, 10, 10, and that is what I'll be passing over here. Then I am setting the color over here. So color is equal to green, and this I will, so when I just have color is equal to G, this is what I'll have over here, plt.show. And as you see, I am able to make a simple bar plot out of this. So India has won most number of matches against Sri Lanka, followed by West Indies, followed by Zimbabwe, Australia, and South Africa. So I'll just show you where I've got this data set. So just write down Cricket World Cup data set, Kaggle, and click over here. And let me just open this particular link over here. Let me see if this is the right link. This is not the right link. Let me just go back again. Right, this must be the link if I'm not wrong. Yes, right. So just type in Cricket World Cup data, Kaggle, and this is the these are all of the data sets which I'm using over here. Right now, the data set which I'm working with is this ODI match totals.csv. So you guys can go ahead and download this data set from over here. So now that we've done this, we'd want to do a similar analysis for the matches India has lost. So for that, what I'll do is I'll have India result, and this time I would set the result to be equal to lost. And this I will store it in this object called as India loss. And again, what I'll do is I would want to check the value counts, India loss opposition dot value counts, and this tells me that during this time period of 2013 to 2019, India has lost the most number of matches against Australia. So India has lost 13 matches against Australia, 8 matches against New Zealand, 8 matches against England, 8 matches against New Zealand. So somehow it would seem that India was able to perform better against the lower ranked teams, and India did not really perform that well against the higher ranked teams. Because if you look at this, India has a lot of wins against Sri Lanka, West Indies, and Zimbabwe during this time period, which maybe, though India has won the matches, but then again, they were quite low ranked during this time period. And if you look at this over here, India has lost matches against Australia, England, and New Zealand, which tells you that maybe they were, the quality of the batting or the bowling from the Indian team was not really up to the mark. And that is why maybe they did not win the 2019 World Cup. So here, I'm going to do a similar plot. First, what I'll do is I will set the figure size, so plt dot figure fig size, and I'll set it to be equal to 8, 5. Then again, I'm making a bar plot out of this. So India lost a position dot value counts, and I would want to get I would want to make this bar plot for only the top 3 teams over here. So I'll have 0 to 3. And since I want only the categorical data, I'll have Australia, England, and New Zealand. Then if I would want the values, I will pass in the same command without the dot keys method. Then again, I'm setting the color. So now let me just change the color. Instead of green, let me actually make it red. And I am printing out the plot over here. You would see that India has lost the most number of matches against Australia. Then you have England and New Zealand closely falling behind. Now, if I would want to make a pie chart for this, so pie chart will basically give me a distribution of, what percentage of matches have we lost against different teams. So again, I'm setting a figure size over here. So plt dot figure size is equal to 7, 7. And when I am making this pie chart, I will have plt dot pie. And when it comes to a pie chart, the parameters what you pass in is sort of opposite of what you do with a bar plot. So here first we'll be passing in the numerical entries, then we'll be passing in the categorical values. So first we will have India lost a position dot value counts over here. So first we'll get all of the numerical entries, then we'll have the labels. So labels are basically the categorical values. So here India lost a position dot value counts dot keys. Then to set the percentage values, I will have this new attribute called as auto PCT. And I am setting percent 0.1 f percent. So this 0.1 will mean that the percentage will be till the first decimal value. And I'll just go ahead and run on this. And you would see that if we look at the overall losses, out of them, 26.5% of the losses have come against Australia. 16.3% losses have equally come against England and New Zealand, 12.2% losses against South Africa, 10.2% against West Indies, and so on. So this is how you can create all of these beautiful visualizations. Now, as we had analyzed this for Team India, similarly, we'd want to do an analysis for Australia as well. So now from this ODI total data frame, I'm setting the country value to be equal to Australia, and I will store it back in Australia over here. And now I don't want to do a similar analysis where, Australia team has won. So here, as you see, country is Australia, and you have the result column over here. I'd want to analyze all of those records where the value of result is equal to 1. So Australia result is equal to 1. I'll store it in this object called as Australia win, then I'd want to see the value counts. You would see that Australia has won 14 matches against England, 13 matches against India, and 13 matches against Pakistan. Now I will again make a bar plot for the top three teams against which Australia has won the most number of matches. So the command is pretty much the same, plt.bar. First we will pass in the categorical entries, next we will pass in the numeric values. And this is what we have. So most number of matches against England, India and Pakistan. Similar sort of analysis where Australia has lost the matches. So Australia result is equal to lost, and this I'll store in Australia loss, and I'll look at the value counts method over here, and you would see that. So if you look at this, so Australia has won the most number of matches against England, and Australia has also lost the most number of matches against England. Similarly, the second most against which Australia has won is India. Again, the second most against which the Australia has lost is India. So third position, Australia had won 13 matches against Pakistan. Over here you would see that Australia has lost 11 matches against South Africa. But if you look at this, so it would seem that Pakistan was never really able to perform well against Australia over here. So in this time period, Australia had won 14 matches. So Australia had won 13 matches against Pakistan, and Pakistan had won only one match against Australia during this time period. So this is something you will get to know over here. So this is an analysis for the Australian team. And now we'll do a similar sort of analysis for England. So from the ODI total, I am setting the country value to be equal to England, and I will store that in this object called as England. So here, this is what I have. If you look at this country column, you will have England. You'll have result, which will tell you if England has won this match or not. You will have the opposition column over here. And I am setting a condition over here where result is equal to 1, and I'll store it in this object called as England win. Then I'll look at the value count so that I know against which team has England won the most number of matches. So England has won the most number of matches against Australia, then followed by West Indies, then followed by New Zealand. And I'll do a similar sort of analysis where England has lost the matches. You would see that England has, again, so if you see at this, England has won the most number of matches against Australia and also lost the most number of matches against Australia. Then England has lost 11 matches against Sri Lanka and 10 matches against India. It would seem that England was not really able to perform that well in the South Asian subcontinent. So they weren't really able to play that well against India and Sri Lanka. So this is all of the analysis which we have done with respect to today's session.
Now let's quickly summarize the video. In today's course, we discussed exploratory data analysis. We discussed the types, advantage, and also demonstration of EDA in Python. And we also understood data visualization libraries and graphs. Then we understood how to do multivariate analysis. After which we understood the different methods of outlier detection. Finally, we did our analysis on Cricket World Cup dataset. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.